Listen to my lies. Love is far to come. Your love is far. Running at the speed of light, kissing under city lights. Calls me in this morning time, but it just goes on. Running at the speed of light, kissing under city lights. Calls me in this morning time, but it just goes on. Gotta get up again. I gotta get up to another day. I'm not giving up again. I'm gonna get up. I'm gonna get up. I'm gonna get gonna get up
open eye, feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you can make me move. You can make me move.
Hello, welcome. How's everyone doing today? My name is 𝙂𝙚𝙣𝙚. I'm a variety streamer. I stream lots of video game chat suggestions as well as I draw art, and hopefully I'll be 3D modeling here for everyone. Welcome. We're starting our next art practice. Pretty much our next art study. All we're doing is pretty much this is more of a pole arm stance. Like, I do have a scythe behind me, and my character is meant to be wielding a scythe. So why not? Hi Flora, thank you for lurking. Welcome. Alright, so we'll have a bunch of stuff ready and stuff like that. This is more of a I'm trying because, as you can see, I'm actively doing like more complex stances so I can poses so I can learn to how to pretty much visualize a pose while keeping anatomy consistent. Alright, chat.
Every 3.9 microseconds, your RAM goes blind. Your RAM physically has to shut down to recharge. You can't stop it, you can't predict it, you can't outrun it. In exactly 3.9 microseconds, we're going to... But you can outsmart it. Croton-on-Hudson, a small town overlooking the Hudson River, about an hour north of Manhattan. Bob Dennard arrives home after a long day at IBM.
Classic investigator.
It's already dark out. He collapses onto the chair. His team is losing. All day, he watched a rival team at IBM demonstrate their memory design.
How are we gonna do
It probably
this?
wouldn't have worked, but it looked good. Really good. Meanwhile, his team's design would need 6 transistors just to store a single bit. There had to be a better way. But what if we only had one?
Really
Calls
don't
his
think.
boss at 10 p.m. His boss tells him to calm down, take 2 aspirin, and they can talk about it in the morning. In that moment, right there on the couch, Dennard had just invented the memory system that would end up inside every computer, every phone, and every server for the next 60 years. There's just one dastardly catch, and it's the same catch that your computer currently has. In order to hold that single bit on just a single transistor, Dennard had to store it as a tiny electrical charge on a capacitor. The problem is, it leaks constantly, kind of like a bucket with a hole in it. If you don't do anything about it, all of your data disappears. So, every couple microseconds, the memory controller stops what it's doing and recharges every cell, filling up all of the buckets. And while it's doing that, you just have to wait. This lockout is defined by the JEDEC spec as TRFC, or refresh cycle time. Now, a regular read on DDR5 might take you like 80 nanoseconds, but if you happen to accidentally get
Here's a good
caught by
cow.
this lockout, that's going to bump you up to about 400 nanoseconds. And that might not sound like a lot, but on modern CPUs, that means you have to burn like potentially 2,000 cycles just sitting there waiting for the drawbridge to go back down. The majority of the time, you don't notice. It's just the physics trade-off that Dennard made, 60 years ago. You're playing a game, you're browsing the web, whatever. You don't even realize that it's happened because it's such an insanely small amount of time. To put in perspective, the human eye takes like 300 milliseconds to blink. In the time it takes you to blink once, your stick of RAM froze and unfroze about 150,000 times. Hold on a second. That's a really bad excuse, and technology never got anywhere by saying, I accept this and it is what it is. Because I can think of at least one field that might really care. Stop. Think for a second. What industry might really care about wasting a couple hundred nanoseconds, where one incorrectly timed stall would cost you millions of dollars? That's right, the world of high-frequency trading. We'll get back to that a little bit later. Take a look at this. I slapped together a nice little benchmark program that's going to make the RAM stalls on DDR4 like really obvious, and it's literally just a flush read timestamp on a tight little loop that targets one particular address, and then I hammer that address millions of times, or like 20 million times to be exact. So on x86, this is going to be CL flush, mfence, RDTSC over and over again. Spun it up on a bare metal cloud instance that uses DDR4 and should only cost like a couple cents. Also, theoretically, our benchmark code should work on basically any DDR4 system. Now, I'm not going to get into all the math here, but because our cloud AMD processor runs at 2.65 gigahertz, that means that we should encounter a spike if we've hit that RAM hiccup about every 20,720 cycles. Side note, measuring time on this level is actually very interesting. Did you know that computers keep track of their own cycles? So with this level of accuracy, we can measure things on the sub-nanosecond level. And look at that. When you plot the gaps between the slow reads, they're all the same, 7.82 microseconds apart every single time. And each one of those is one of the refresh stalls happening that we can physically see happening. Those are literally the leaky capacitors recharging. But the question is, if we can see it, can we predict it? Now, I've got a little idea. Now, for the majority of programs, you don't care about these kinds of periodic spikes over here. But if you're working with super low latency applications, like with high frequency trading, for example, you don't just care about average latency, you also care about determinism. So wouldn't it be nice to be able to reduce what we would call these P99 or P99.99 spikes? Now, it doesn't happen often, but if one of our reads lines up perfectly with one of the refresh cycles, that's going to suddenly add hundreds hundreds of nanoseconds in latency to our operation. So the question is, if this is so periodic, can we potentially predict when the refresh cycle is going to happen and then try to read around it? You would think that if we put a read here, we could be like, okay, the next one's going to be the refresh cycle, so we're not going to read now for a little bit. Or even conversely, if we put it here, we could be like, okay, yeah, we've got like 6 microseconds of room left, we should be good. It gets a lot more complicated than that. I had this whole theory going where you would just pick different regions in memory that had refresh cycles that were uncorrelated to each other, and then when this one was about to experience a stall, you would just go over and read from the other one and be good to go. It's like dodgeball, where we dodge the spikes that are about to hit us. See, it's not like the whole stick of RAM gets locked when the refresh cycle happens. It's a lot more granular than that. With DDR4, for example, the refresh happens at the rank level, and then DDR5 gets even more complicated where you can like subsection down even further than that. So every night I was going down a rabbit trail trying to code a strategy that would work around this. None of that matters for the video. Did it work? This doesn't work at all. This is a really important lesson in statistics. Being able to see a rhythm is not the same thing as having a really reliable countdown clock. We can see the beat after the fact, but what we were measuring previously was the downstream effect. We didn't really have to worry about predicting caches, queues, contention, OS scheduling, and all this kind of stuff that makes our spike a little bit fuzzy. There's also a problem in the JEDEC spec that absolutely kills our ability to predict this. Pulling in and postponing refreshes is explicitly allowed. The memory controller does what's called opportunistic refresh scheduling, which basically means that it can postpone up to 8 refreshes and then catch up later if we happen to be in a busy period. So most of our spikes happen every 7.8 microseconds, but it's not like an exact metronome, it's more like an average budget. So even if you get just a tiny bit off, you progressively get worse and worse and worse. And considering that this happens like 100,000 times a second, you progressively get just incredibly off. Basically, for a very, very short window, my strategy would work, but then in a blink of an eye, it would get incredibly off, because how the heck are you going to predict opportunistic refresh scheduling? So not gonna lie, I was really down in the dumps for a while because I didn't think it was going to work, and I almost scrapped this entire video. But Mama didn't raise no quitter. I knew I just needed to think a little bit harder. Back to the drawing board. Seattle, a small town overlooking Puget Sound. About 44 hours west of Manhattan, Lori Wired arrives home after a long day at Google. It's already dark out. She collapses onto the chair. I can't do this anymore, she thinks. I've got to read something else. Changing her routine, she grabs an old ACM issue. It looked good. Really good. Of course, that was in the web server world. Meanwhile, her design, in the land of low-level memory, was messy, complicated. There had to be a better way. Wait, what if I did the same thing? She calls her mom at 10 p.m. Mom, I've come up with a new strategy for RAM reads.
Okay. Whatever that means.
What do you think about that?
I think that if you thought of it, it's a good plan.
All right, legitimately, all jokes aside, there's something really interesting here. If we take a little bit of a closer look at Google's The Tail at Scale paper, which talks about reductions in tail latency, this was published back in February of 2013 in the ACM Communications magazine, and they used some really interesting techniques, such as hedged requests. Now, I highly encourage you to go back and read the actual paper itself, but the primary thing that you need to take from this is that web users really care about reduction in page latency. Instead of doing a ton of advanced work to try to speed up one single machine, what they do is just duplicate it, send the same web request to multiple machines, and then pick whichever one is the winner. And then they'll just drop all of the loser requests that didn't make it fast enough. And this is honestly like a super intuitive, kind of obvious concept that's cool, but unfortunately it's such a different domain than what we're working with here, because they're working like super high level with thousands of different machines, and then they're working with millisecond latencies. We're working on a single box with the lowest level of abstractions, trying to reduce latency in the nanosecond range, so orders of magnitude smaller. But I've I've got a hunch that it could work. It's always gonna be way more fun to explain things with toys. Now imagine that we have a simple move instruction in assembly, and this entire thing represents our move instruction. It's very accurate. So you see we have our train path over here, and then our drawbridge is going to represent our TRF stall. So you can see. Here we go, that's our stall. And then our train is going to represent a memory request being sent from the CPU. Doesn't this just look like a triceratops? First it crosses the data fabric portion of our trip, and that's gonna last about 15 to 20 nanoseconds before it hits the memory controller station right here. And that can be like 5 to 10 nanoseconds, maybe a little bit longer. And then we switch over to the DRAM portion of our trip, and that's gonna be where our drawbridge lives. Oh no. Here we go. Come on. A little bit of help. If our RAM isn't busy, then we can just, pass on right through and continue on with our request. But if it is busy and it's in the process of performing a request, then our drawbridge is up and our train is stuck there, and it just has to sit there and wait for the refresh to finish. And this is an excruciatingly long amount of time because we can wait for like 400 or even 500 nanoseconds. We are stalled, everyone. I wonder what would win, train or drawbridge? Oh, apparently train wins. Look at the smoke on that. That is just like the coolest thing I've ever seen in my life. Trains. Once the drawbridge opens back up, the controller can start servicing the request. Now, if the right row isn't already open, the controller issues an activate command. In the JetX spec, after activate, you wait TRCD before you can issue the actual read, and that's gonna be like 15 or so nanoseconds. Activate? Woo! Okay. Good timing. Then we can actually read the memory, and this is where our CAS latency comes in. Column access strobe. And no, CAS here does not stand for compare and swap if anybody's into lock-free or wait-free programming. Go take a look at a stick of RAM and you'll see it has the CL number on here, if you can see it. And what this number is this is actually the CAS latency measured in clock cycles. So this particular one has a CL number of 30, and what that really means is it takes exactly 10 nanoseconds in wall time. You'll notice that more expensive RAM tends to have a lower CL number, and in some industries they'll pay like a super heavy premium in order to minimize this. And this is one of the only pieces of the track that you can actually reduce. After that, we take a few nanoseconds to go over the DRAM bus, and then finally we go across the fabric to the CPU, which is going to be another 15 to 20 nanoseconds. Yeah. We made it. I'm going to smoke right here because then he's going to go like super fast down, and then he's going to just like break through the smoke. Oh my gosh. That's just sick. Peak content. So what can we do? Like I said, this is the only part of the track that we can replace to make a little bit shorter, but even if we do that, if the drawbridge is up, you're still kind of screwed over here. But what if we built a second track and then had 2 trains? And voila! Same starting point, but we have a completely different channel that we can go through. So basically what we did is we just have an identical copy of our memory in a different location. That means we can have 2 different drawbridges as well. And if we're kind of clever about it, we can pick a second drawbridge that has a completely independent or uncorrelated schedule to the other drawbridge. Now what we're gonna do is we're gonna send 2 trains at the same time. So that means that even if this drawbridge is up, this one is probably down. So whichever train reaches the end first wins. Okay, let's do our data race. Here we go. And we got this drawbridge. It's gonna be the one that's up. Get a little bit of help. Yep, there we go. Oh no, this one's stuck. Here we go. We're still reading our data. Over the CAS. Woo! Come on. All right, he won. And now this one finally goes down and can finish, but he's like super super late to the party, so who even cares? He also sucks at his job. For the other one, we just throw away the cargo because we already got what we wanted from this guy over here, so who cares? Now all this sounds really simple, it's just hedged reads, but shrunk down to the nanosecond scale at the lowest levels of hardware. There's just one tiny problem. So here's the thing about modern CPUs. They have something called out-of-order execution. Now imagine we have two different move instructions in assembly, and one of them happens to be reading something from channel A, and the other one happens to be reading something from channel B. Well, these requests can actually fire at the same time. What happens is the CPU's out-of-order engine analyzes these instructions and then realizes they're independent from each other. They have different source addresses, and they have different destination addresses, so it sends both requests off through the cache hierarchy. They both miss in L3 cache and then get sent off to different memory controllers. And boom! Both trains are off, moving in parallel. They might be like one cycle apart, but it doesn't really matter. This is more than one cycle apart. It's perfect, everyone. It's perfect. Completely synchronized. I used to have a recorder growing up, and let me tell you, those are great for kids, but they have to drive everybody else around them absolutely nuts, because I remember I would just like have all my fingers down and like have one up and I just go
Aww.
You might be saying, well, what's the problem? It seems like the concept should be working just fine and they're running in parallel to each other perfectly. Well, the problem is, for our specific scenario, we're going to encounter a tricky little quirk. I think he's racing other data. We're going to encounter a tricky little quirk known as a Rob stall, or head of line blocking. The problem isn't like the dispatch portion of it. We blow the whistle and they both start at the same time and they're running in parallel. That means if one drawbridge happens to be up, then the other one can theoretically win. Here's the frustrating part. We've got this guy over here stuck by the drawbridge, so this guy's going through. Looks like he's gonna win. Doesn't matter if this guy's stuck, because this guy can keep on going. But then he stops right there. And he sees it. The CPU register is right in front of him, but there's just this invisible wall stopping him from getting there, leaving enough time for this guy mosey on. So he takes his time to then win. So what just happened? Well, remember, it's not the dispatch portion of this whole thing, it's the retirement. You have to commit instructions strictly in order every single time. And why is that? Well, modern CPUs are constantly speculatively executing hundreds of instructions ahead, assuming everything goes right. But what if something goes wrong? Your CPU has to kind of hit the undo button, but in order to be able to do that cleanly, it has to know exactly what instructions were executed, in what order they were executed, and up to a specific point. And that is the reorder buffer. It's kind of like this sequential checkpoint system. So the CPU can't finish processing the fast request until the slow one has also completed. The fast read came back with our data really quickly, and the CPU might even start doing some math with it speculatively, but it can't commit any of those changes because it had to wait on the stupid slow read that got stuck by the drawbridge over here. Eventually, the buffer just fills up completely, and the core just grinds to a halt. Sad. So no, you can't hedge on a single core. Unless... well, guess what, buddy? It ain't 2004 no more. We have multi-core processors! But you might be saying, oh, well, why are you so excited? Well, because it is exciting, because separate cores have separate reorder buffers. That's right, everyone. If we fire off these two different reads on two different threads on two separate cores, they can both run, hit a TRFC stall, whatever, it doesn't matter, but they're not going to get caught by any arbitrary invisible walls at the very end. So we solved it. It probably sounds pretty obviously, honestly, right? So now all we need to do is write a little program that's going to take our data, replicate it on two separate memory controllers, so that way we don't have the drawbridges hit at exactly the same time. So piece of cake, right? Right? operating system doesn't really like it when you can find out physical memory addresses. Something about security.
I'm just being dramatic here. Every good programmer knows this already, but it makes it more fun.
See, I'm gonna go over here, write a little program, allocate some memory, and we'll get an address back. It looks like a real address, it feels like a real address, but it's not a real address. It's fake. The OS made up this address, and this is called a virtual address. See, every single program on your computer thinks it's living in this kind of happy little dandy world where it has the entire machine dedicated to just it and its execution. And it kind of makes sense because if programs could mess with the physical memory of other programs on the machine, it could cause like a ton of different problems. The real address, the physical one that actually corresponds to a location on your RAM stick, is hidden from you. So behind the scenes, the operating system is performing this entire remapping process, and it really doesn't want you looking at it. It's shy, everyone, okay? Anyway, this wouldn't be a problem, who cares, unless you're trying to do something really specific like, I don't know, trying to make sure your data appears on 2 separate memory controllers. Let's say I want to run a little experiment using offsets, and I take 2 copies of my data, and I space them nicely 128 bytes apart, and I'm feeling pretty good about myself, but for all I know it could be straddling a page boundary, and then the OS could have decided to put them wherever it felt like putting them, and with that, my entire hedging strategy is completely ruined. It's okay, Lori, it's okay. Now luckily for us, there's a cheat code, and this cheat code is called 𝙂𝙬𝙖𝙀. So normally if you're working with Linux, for example, the OS will give you 4 kilobyte chunks kind of scattered all over the place. So you might think you have this 1 megabyte of contiguous space altogether for yourself, but in reality it's just 256 scraps scattered all over the place. I'm Linux, and this is what I do to your RAM. As soon as you cross a page boundary, everything kind of gets messed up and you could get theoretically transferred basically anywhere. But if you ask nicely, and by nicely I just mean you pass an additional flag over to a system call, you can get a huge page. And a huge page is one big contiguous block of memory. And more importantly to point out, it is one physically contiguous block of memory. Now, virtual address plus 128 also equals physical address plus 128, as long as you're working inside of the huge page that we've allocated. And we've allocated so much that it's actually large enough to be able to play around and experiment inside of. So yeah, no more vibes, just math. Everything's going according to plan. Unfortunately, there's yet another layer of abstraction that we have to deal with to make this work. Most computers these days use a 64-bit addressing mechanism, but in practice, if you're looking at x86 64 systems, in reality, they only really use 48 physical bits to represent the memory addressing portion of it, or 52 bits if they're like a really large system. But even just using those 48 bits, that still gives you the ability to address 256 terabytes of memory addresses, or even 4 petabytes of memory addresses if you're going for the 52-bit option. For our purposes, that means that somewhere inside of those 48 bits, some combination of values is going to determine what memory controller that your data is actually going to end up on. I don't think that's a valid memory address. Okay, that almost spilled my water. Remember how we're trying to get copies of data for our hedged read to end up on basically 2 different drawbridges? Well, that kind of implies that we need to reverse engineer how the memory controller really maps these addresses over to the real physical locations. And you might be thinking this is probably like some predictable linear type thing, like maybe the lower bits correspond to the row, the middle bits correspond to the bank, the high bits correspond to the column. But it's really not like that, like, at all. Every modern CPU, whether that's Intel, AMD, ARM, doesn't matter what it is, takes your address and runs it through a set of undocumented XOR hash functions, which scrambles up where your data actually goes. So even if you bypass all of those OS level primitives that are actively working against you on this, and you do end up with 2 addresses that are physically right next to each other, let's say like address hex 1000 and address hex 1040, which are only like 60 64 bytes apart from each other, they could still end up on completely separate RAM sticks. What's even worse is even if you did take two physical memory addresses that were really far apart from each other, let's say we've got address hex 1000, and then we've got address hex 8001000, which is 128 megabytes apart, they still could end up on the same stick, channel, and bank. So why the heck is that? Well, with everything we've been doing, there's been a good reason for it, and same thing goes for this one. It just makes our specific use case really difficult. First reason why all memory controllers do this kind of scrambling is performance. So here the hardware engineers are kind of compensating for potentially lazy programmers. Now picture this. Let's say you're stepping through a really big array, and all of the elements inside of the array are evenly spaced, and you're performing all of your mapping in huge pages. If the memory controller didn't do this kind of scrambling, then common access patterns like stepping through an array sequentially would continually hammer one bank of RAM over and over again, while all the other banks and subchannels just sit there completely idle. You have to remember that these might look like just two sticks of RAM, but they're actually broken up into 4 independent subchannels, each with 32 banks. So the XOR hashing phase kind of acts like a load balancer baked like directly into the silicon itself. Takes in your physical address, does a little bit of scrambling, and tries to spread it out evenly across all of the banks and channels. I'm your friendly neighborhood XOR hashing load balancer. That's for DDR5, by the way. Even if your lazy programmer wrote a memory access pattern that's super linear, the hardware makes up for it on the other side, adding all of this kind of randomization. There's also a much darker reason. In 2014, at Carnegie Mellon University, a PhD student named 𝙂𝙚 Kim was studying DRAM scaling issues. Their group was specifically studying DRAM reliability, and they wanted to know how memory would behave as modern-day node sizes progressively shrunk and got more dense. Now what they did is they created this neat little test bench memory controller that would allow them to issue raw DRAM commands so they could specifically target individual rows and watch what happened. Turns out, if you open and close the same memory row fast enough, you can flip bits in the row next to it. Basically, aggressive activity in one place physically disturbs the neighbors. They published their results in their 2014 paper called Flipping Bits in Memory Without Accessing Them, an experimental study of DRAM disturbance errors. That's a mouthful. They just called this technique row hammer though, and the danger was clear from it, but they deliberately stopped short. In section 4, they state, with some engineering effort, we believe we can develop code 1A into a disturbance attack that injects errors into other programs, crashes the system, or perhaps even hijacks control of the system. A few months later, a few researchers on Google's Project Zero team took this technique and weaponized it against the operating system. So you could take like a completely unprivileged process, no root, no admin, no nothing, just a normal process, and completely take over the machine just by reading their own memory in the right pattern. The scariest part is that memory manufacturers probably already knew about the problem, because in June of 2012, 2 years before Kim even published his paper, Intel filed a patent called row hammer refresh command. That means that they were already filing a patent for the fix before anybody even knew there was a problem. Spooky, right? Here's why I told you all of that. So DRAM hashing strategies were already not documented publicly, but then after the entire row hammer thing, obviously there was even less incentive to publish these load balancing math strategies publicly. To pull off the classic double-sided row hammer technique, you have to have and hammer two physical memory addresses on two different rows and sandwich the target in between those two rows. But in order to make that happen, you have to understand how the memory controller works and how the memory addressing works. Kind of like a security feature. It's not a bug, it's a feature. And my project is just kind of like an unintended victim. Now, even though I'm not trying to do any kind of malicious bit flipping, it really doesn't matter. Intel and AMD are not going to make it easy on us regardless of the intent behind the project. So I did what any reasonable person would do. Buckle down, pull out a little bit of math. We're going to reverse engineer the undocumented channel scrambling for Intel, AMD, and Graviton. Good news first. So for my hedged read theory, I don't need to have the same level of granularity that you would need to have for performing an entire rowhammer attack. All I need to do is make sure that I have multiple copies of data that end up in relatively uncorrelated locations in memory. Honestly, even just like 2 separate channels would be totally fine. That way I can make sure that I don't encounter a stall at the same time when I'm performing an access. And unfortunately, there's a lot of different bundles of reasons why CPU manufacturers make this specific idea difficult. What we're doing is not exactly in the user manual. Part of the reason is competition, because knowing the hash function kind of reveals some of the different architecture and design trade-offs that you made, and you don't want to just like openly publish that for your rivals to be able to see. You might have different design decisions and philosophies for how your memory controller handles locality and distribution, for example. So if you understand those hash functions, you also kind of understand the core architecture trade-offs. I'll show you some of the results shortly, but one tidbit that I did figure out is that AWS's custom Graviton ARM chip uses exactly the same channel addressing as AMD's EPYC, which is x86. So the bit positions are completely identical. And even more interesting than that is Intel uses a completely different strategy. So there's not like some physics reason that's saying why everybody needs to use an identical strategy. It just goes to show that behind all these closed doors, these architectural decisions are actively being made by CPU designers. We have to do what I did to be able to see them. But for all of this as well, it's also about performance flexibility. This address hashing can change per SKU, per CPU stepping, per BIOS setting, per microcode update. If AMD and Intel documented this kind of stuff, they'd kind of be like locking themselves into a strategy because customers would start to build against it. And then next year when it comes around, it's really going to make your life difficult because you're not going to be able to change things nearly as easily. But if you just don't document it, well, who's gonna complain? Only weirdos doing crazy stuff like me. There's also the security angle. It's kind of like security by obscurity, and I am the obfuscation person after all. But pretty much if you keep all of this undocumented, it's going to raise the bar significantly for being able to perform these rowhammer style attacks, even if there are also other mitigations as well. But basically, from the CPU manufacturer perspective, there's no legitimate use case. Nobody at Intel is thinking, hey, some random girl in Seattle wants to replicate data on 2 different channels and race them. The vendors all assume that their address hashing is transparent to developers, and this is true for throughput, but I care about gosh darn tail latency. It's okay, because we can still do this. I got this. I started with AMD first, mostly because my editing PC is Zen 4 and it's kind of nice to be able to really hammer at a machine without that voice in the back of your head saying, oh, you're wasting cloud dollars. Here's the thing that most people don't know. Inside of your CPU, right next to the memory controllers, there's actually tiny little hardware counters, one for every channel. They tick up with every read that goes through that channel. Now AMD mostly put them there so performance engineers could monitor bandwidth. That way you can run your simulation and be like, oh, there's too much traffic going through on channel 3 and it's overloaded. I guess my traffic's not balanced. And no CPU manufacturer really cares if you get this kind of information, so they don't mind exposing it because it's kind of mundane. If we do a simple sudo mod probe AMD uncore, it reveals those hardware counters to the standard Linux perf tool. Now if you've never used perf before, it's a pretty cool tool. We mostly use it for measuring cache misses, branch miss prediction, CPU stuff kind of like that. But if you load this module, that exposes those extra hardware counters to you, which most people don't even know exist. Now you're one of the special few. Here's the thing, if I write a tight loop of code that constantly flushes the cache and hammers one particular memory address, then that means one counter should start to light up. And theoretically, this should tell us exactly what channel that our data is living on. And the code for this is kind of deceptively simple, but you really have to understand all of the previous architecture knowledge to get to this point. The flow is basically allocate a huge page, because remember that gives us a ton of physical, real offsets that we're able to work with, and then we pick stick an address somewhere inside of that huge page that we've allocated, and then we have our nice little x86-64 inline assembly loop. Inside of that assembly loop, first we need to flush the cache and evict that, so that's our nice little CL flush instruction. Otherwise, the CPU might cheat and try to read the value from LL1 cache, and in this particular case, we kind of want the inefficiency. Then we wait for the flush to finish, we force the read, and then we're complete. Moment of truth, let's go! That's kind of weird, can't really tell what's going on here. Well, that, my friend, is OS noise. Even though we have a really minimal Ubuntu install, there's still like a ton of processes happening in the background, performing reads that could be interrupting us and causing additional noise. The problem is these counters are pretty dumb, so you can't tell it only count the reads from this particular process. So what does that mean? Is it so over for us? Nope, not at all, and the fix is actually really easy. All we need to do is run it 50,000 times. And that might sound like kind of a lot, but it's really not, because CPUs are so fast, this only takes like a few milliseconds of wall time. In fact, it's so fast that I can't even show you a loading bar. Wow, see that spike? Super cool. And now I really know where my data lives. But here's where the fun part really begins, because let's flip one bit and do it all over again. Hold on a second. What about all the XOR hashing stuff? Isn't it more complicated than that? Well, technically yes and no. For rowhammer, you need to know the entire hash function, every XOR, every bit, basically the entire mapping from address to row to bank, since you need to know exactly where you're gonna land. I do not need this information since I'm doing a performance engineering project. So to me, I don't really care which channel I'm ending up on, whether that's channel 3, channel 7, whatever, it doesn't matter to me. All I need to do is make sure I'm ending up on different channels. So that means I'll end up with different drawbridges, and so their stalls are going to happen at different times, and my hedged read should work. The mathematical answer is that XOR is linear over GF2, which is actually really simple. Basically, that means that no matter what scrambling the memory controller does, flipping a base bit will always flip the output no matter how many things are chained together. And that means that we don't have to reverse engineer the entire black box, we just have to be able to observe the input and output behavior. This here represents my AMD Zen 4 memory controller. These represent my physical memory channels on my AMD system, and I'm on a consumer box, so there's only 2 of them. And then these are going to be the bit positions 6, 7, and 8. And I'm going to do this in demonstration form and in the code so it makes 6, 7, and 8.
You're 7:30. Oh, I as soon as I heard it, I have to accommodate. There we go.
And I'm going to do this in demonstration form and in the code so it makes complete sense. All this is running on my Zen 4 system. If you know binary, I want to flip bit 6, so I'm going to offset my data 64 bytes. Same channel, tester code again. Yep, same channel. Bit 7, 128 bytes, tester code. Yep, same channel. Bit 8, 256 bytes. Different channel. So wow, 256 bytes apart and we end up on a completely different memory controller. Now if we do this for every single bit, we end up building up this kind of map about how the memory controller routes your data. Some of the bits are going to matter, but most won't. But essentially extend this out for 24 more bits. Anyway, 256 bytes apart is all it takes for this particular system, which doesn't really sound like that far apart, but that means they're going to end up on completely different channels and controllers. And most importantly, they're going to have independent refresh cycles, aka different drawbridges. So that's AMD. And once the code was written, it takes like 30 seconds to map out a system, so really the hard part here is knowing what you're looking for.
Oh, nice.
After all that, the virtual memory, the huge pages, the bit mapping, the XOR hashing, etc. You know what my hedged read strategy looks like?
Here.
It's just 2 addresses, 256 bytes apart, pinned to 2 separate threads, and then you just take whoever wins first. I think there's a song for this. It's like, it's so simple that it's complicated. So let's see what happens. Side note, I cannot stand Lil Wayne. Absolutely not. But you know who's really good is Childish Gambino. Let's take a quick look at our benchmark code. Now, the majority of this code is just extraneous. It's related to setting up the benchmarking portion of it and then performing the measurements after the fact. But if you want to look at the core portion of this, it's surprisingly small. Just take a look at the measurement thread function inside of our benchmark class, and this is performing the actual read portion as well as the measurement of the amount of cycles that something took. If we dig further into the benchmark portion of this, we can see we have this kind of what I like to call a benchmark sandwich. So we start out with our little CL flush instruction, cache line flush, evicting that from all levels of the cache so we can make sure we're reading directly from RAM and not messing up our benchmark times for that. Then after that, we have our barrier instructions, these fence instructions over there, to make sure that we're not executing instructions out of order so we do actually get like a correct benchmark time. And then of course we have our time reader, we have our RDTSC, read timestamp counter, and then at the very end of that we're going to be subtracting these times from each other so we can get the total number of cycles that it took to perform the operation. And this is going to be our wall clock time, so it's going to include the stall if we happen to get that during our actual RAM read. And then at the very heart of the code in the center, sandwiched by all of this, we have our actual read of the address. So this is dereferencing the pointer and storing this inside of our val variable. All right, 20 million samples on my 7950X3D dual channel DDR5 Zen 4 Ubuntu 2404 machine. Let's go. This is what's called a CCDF chart, and it's actually pretty simple to read. Just pick any point on the line, and the y-axis represents what fraction of reads were slower than that. And then each tick on the y-axis is another 9. So you have your P99, P99.9, P99.99. So basically, each tick down is 10 times rarer. The red line we have plotted right now is the latency distribution of a traditional read. Basically, further right and up is worse, and further left and down is better. Now let's plot my hedged read in blue. Wow, it really works! So if you take a look at our P99.99 over here, so that's our 1 in every 10,000 reads, you can see the regular read strategy took 631 nanoseconds, but my hedged read strategy only took 281 nanoseconds. So it really works. If you go down to the really rare stuff, you'll see that our regular read is getting reads up to a microsecond long, which is way worse than our hedged read strategy. Now, whether that's because of controller contention, a stall cycle, or a bank conflict, or whatever, doesn't matter because that's happening on one channel. If we go to our hedged read strategy, we still have another whole channel, so we don't care. This is an insane difference in tail latency, and so we've really proven that it works. On my system at least. But does it work everywhere else? Time to rent some hardware. Hey, guess what? More channels actually equals more hedging options. So on my wimpy consumer board, I only have 2 channels, but most servers have way more channels than that. So as long as we figure out where each channel is, we can expand our strategy to have more copies of our data. So it should scale really well. Because the AMD Uncore performance counters are pretty stable across AMD generations, I really didn't have to change my channel discovery code that much to be able to support AMD EPYC systems. It really just comes down to more combinations of bits and offsets. As of today, AMD Turin, which is Zen 5, is the latest available AMD server architecture. So we'll just go over into Spot instance real quick. That's bare metal. This one is C8A Metal 24XL. And it's only like a few dollars. It just blows my mind. Running it again. And here we go. Wow, so our blue line is almost vertical. That means our tail latency, our worst latency here, P99.99 and further, is almost the same speed as a regular DRAM read. So that's like absolutely crazy. That means our tail latency at P99.99 is literally 9 times better than our regular read. So our strategy is scaling really well. Keep in mind that's with the stress threads hammering the system, but the crazy part is that even with a completely quiet system where nothing else is happening, we still get a 5 times speed up, which is crazy. Well, you have to think about it that the refresh stall doesn't just go away just because the system's quiet. No matter how you slice it, it works. We're actually avoiding the refresh stalls in software. So you might be saying, well, that's neat and all, but what about Intel? Well, fortunately for us, Intel has the same kinds of per channel counters. They're not called the same thing, but they work in basically the same way. So all we have to do is build the tool, scan the bits, make the map, and then once we have the offsets, we can run our benchmark code on a lot of different cloud instances. And watch this. 2-way hedge, 4-way hedge, and 8-way hedge. It's the perfect result. It's basically like a straight vertical line. So for a P99.99, it's only 113 nanoseconds. That means it's 15 times lower latency at the P99.99 than our traditional read. This was the Sapphire Rapids C7i Metal 24XL, but it also worked on the latest Intel generations I could find too. Granite Rapids C8i Metal 48XL. AWS runs their Granite Rapids instance in SNC3 mode, which limits how many channels we can use for our hedge read, bringing us down from 12 to 4. If I could get into the BIOS to disable subnuma clustering, then it could be even more efficient, but it's still pretty darn good with a 7x improvement. Now here's where it gets really interesting. Previously, when we've been working with Intel and AMD, they've both had those nice little hardware performance counters available for us to use to be able to map our channels. But what if we didn't have those performance counters available to us? AWS's custom Graviton ARM chip is super cool, but it's like essentially a black box. They don't have any custom modules you can load, they don't have any performance counters, and no documentation. How do you reverse engineer something
I don't call
when
you
nothing is exposed to
Z
you?
or
I
G.
might not have my performance counters available, but I do have something
Hey Z,
arguably
welcome,
better.
welcome.
The hedge read itself. So
Bit of doing another art study here. More focusing on mastering poses while keeping anatomy consistent.
if you think about it for a second, I don't know which bits correspond to what channel I'm on, but if I keep on executing my hedged read and measuring the tail latency and then iteratively flipping bit by bit, I can still build out my map. If my two copies of data end up on the same channel, then we should see no improvement at all inside of our hedged read strategy. But if they do manage to end up on two separate channels, then we should be able to see a large improvement in our tail latency because, again, independent refresh cycles. So we sweep every bit. Bit 6, flat. Bit 7, flat. Bit 8. There we go, and there it is. And the tail latency improvement is my signal. No documentation, no performance counters, just statistics and timing. It's kind of funny. He's the thing I was trying to build as the tool to figure out how to build it. Inception. Escher would approve. I am a strange loop. Now I had to do a bit of extra statistical analysis under the hood, a pairwise independence test to make sure what we were seeing was actually different channels and not just noise that we were looking at. But you're welcome to check all of that out on GitHub. Same goes for all the rest of the code for this video, which I'll link to in the description of this video. But the point is, we were able to figure all of this out with just math. Hey, remember when I mentioned you'd learn some interesting tidbits about CPU architecture from this research? Take a look at the bits that I figured out in Graviton 4 and AMD's Turin. Interesting, right? Make of that what you will. Now we take a look at our Graviton CCDF, and yep, we get almost a perfect vertical line again, which is a 9x improvement for our P99.99. And at this point, I'm pretty confident to say that this technique works on basically everything. So I went ahead and tested this on about as many machines as I could get my hands on. And long story short, a few bare metal cloud instances later, we have Intel, AMD, DDR4, DDR5, x86, and even ARM. That tail latency's gone. Once again, research for each platform is all available on GitHub if you'd like to check it out. Well, I think that this technique deserves a name, so I christen it Tail Slayer. And you might be thinking, well, graphs are well and good and everything, but how could you potentially use Tail Slayer in real life? Well, remember that HFT scenario that I mentioned previously? Imagine this. You're running an options trading strategy. Maybe you have a bunch of CPU cores or even GPUs that are working on some ML algorithm that's pre-computing some massive pricing table and like really big, maybe 10 tens, if not hundreds of gigabytes for your working set, aka way too big to fit in L3 cache or in the SRAM of an FPGA. A packet of market data comes in, and you're going to have to read one specific value from your giant pre-computed table that's sitting there inside of DDR5, but the problem is you basically have no way of being able to predict what entry you're going to need until that market data comes in. So the problem is this is basically going to be guaranteed to be a cache miss, and you're going to have to read from RAM. Here's the setup. We're using this specialized NIC, something like this SolarFlare X2522 on load, where you can program multiple receive queues. You've got one packet of multicast data coming in, and that gets sent to 2 cores, but you have strategically used the offset mechanism, so you have 2 copies of your massive data, but they're at different offsets, so they're going to end up on different channels. Now what happens is the packet comes in, each core independently parses that packet, sends off the read on the 2 different independent channels, and then computes the order. If core 0 ends up hitting a DRAM refresh cycle, aka getting caught by the drawbridge, well, core 1 doesn't care because it's on a completely different channel and it's completely independent as well. So if core 1 ends up finishing first, it just goes ahead and fires off the order. On some specialized NICs with programmable FPGAs like this Exynic X25, you could also program some logic into the NIC itself to be able to deduplicate packets. That way, when core 0 finally finishes processing its request after getting caught by the drawbridge for a while, like 400 nanoseconds later when it finally does send off its order, you know that your custom logic can just go ahead and drop it. You've basically programmed it to drop all loser packets, so that way you don't have to worry about any kind of like double send problems. You also don't have to worry about any kind of synchronization between the cores, because the point is they have to be independent. As soon as you start trying to add in atomics and stuff, it just completely kills the point of TailSlayer, and I'll get into that in like just a second. Pros and cons of this. So if you're using this kind of methodology and you're using TailSlayer and stuff, this does require you to burn an entire extra core for processing your RAM reads, but if you're running on like a gigantic server that has like 96 cores, the point is you've really reduced your tail latency here, and it's very consistent. So you don't need to worry that one random DRAM refresh cycle is going to completely mess you up. On these hot paths, a 400 nanosecond stall is a very large amount of your processing time, and TailSlayer can theoretically kind of help mitigate that. Now what you're trading is a very large amount of data that you might be duplicating. Like if you're having 2 copies, you're doubling your RAM usage, and you might even be using more depending on how many copies you're making, but you're trading that for near determinism in latency. I've done a lot of research into this topic, and no public documentation exists for it, so I genuinely do think that TailSlayer is a new methodology. Or if by any chance some company happens to be using it, they're not documenting it publicly and they're kind of keeping it a secret, in which case, sorry for revealing it. Now, the moment you've all been waiting for. Time to see TailSlayer in action. Well, kinda, sorta. It's like a simulation of action. But anyway, this is not really the benchmark code officially. This is how you might use TailSlayer in real life inside of your code. If we take a look at our worker function, it still looks similar to our benchmark code, but we've stripped out a lot of the extraneous stuff, and we just have that kind of sandwiched center portion that's doing the read. The first thing we have to do is pin it to a core, so it's sitting there waiting, so it's ready to just fire off the read as soon as whatever data it happens to be waiting for comes through. So you're going to pin it to as many cores as you need to have duplicated data for. Don't forget, the number of duplicates equals how many channels you're going to be using. So you have kind of this upper bound where you can't use more channels than you have available on your system. Inside the code, I had to have some kind of unbiased timer. Normally that would be a packet incoming or something, but I just use like the number of cycles that have elapsed since we started it to signal off each independent read, which does work, but it's really stupid, so don't do this. But anyway, inside of here we have our actual read portion of it, and then I had some little bit of additional benchmark code left. But then at the very end we would do our processing, which I just did std_cout, but again, don't do that. Process the packet and then send it off. The point is that all of the processing logic is interleaved inside of this, so it's kind of just happening like a spinning on the core and then sending it out. That's my interpretation of it. For the story that I promised, I tried to have just the most minimal amount of synchronization between the threads, so I had just one atomic variable that I was sharing, and then the main thread would know who got their data first, but the overhead of adding the atomic inside of my code just completely ruined the entire point of Tailslayer. But if you go through and you have all these independent copies on independent cores, then Tailslayer works beautifully. As always, thank you so much for watching, everyone. I hope you enjoyed watching this video as much as I enjoyed making it and doing all of the research for this project. Don't forget to leave a comment below if you have any ideas on how this project could be extended or potentially used in more real-world scenarios. Till next time, Word Wired out.
Yep.
Ever since the release of Episode 8, the Digital Circus fandom has had a lot to talk about. Spoilers ahead. From the torture sequence revealing the cast's biggest fears, to Kane getting deleted, Queenie being officially seen for the first time, the uncertain future of the circus, Strategy hugging, Zooble with Paws canon. We got to see Zooble with Paws. I've been making fan art for so long of Zooble with Paws, and it's finally canon. It's not the point.
Hmm?
This isn't a video with Paws, and it's with Paws canon. We got to... It's not the point. This isn't a video.
It is the point.
What I'm trying to say is that Episode 8 has given the fandom plenty to talk about, but one of my biggest takeaways is something that I don't think I've seen anyone else bring up, which is shocking because I thought it was so significant. That being how Episode 8 has seemingly completed Pomni's character development. Now, 2 out of the 3 times I've discussed this topic with my friends in real life, I've actually been asked, wait, like, what's her character arc again? And you might be asking something similar. Isn't Pomni just the protagonist? Like, sure, she's silly, anxious, kind, mean, like, she's got a lot of character to her, but ultimately she's kind of just the everyman, right? And in some ways that's true. Pomni is the straight man of the digital circus. The audience is meant to see this world from her eyes. But if you look closely, there is a lot more to her. In this video, I'll analyze Pomni and how she develops through the series, going by episode basis. In the end, I'll highlight why Episode 8 was the perfect ending for her character arc, and what we can expect going forward into Episode 9. One day, while urban exploring a random building, a young woman finds an old 90s computer and a VR headset. Seemingly out of curiosity, she puts on the headset and finds a colorful video game. She tries to take off the headset, and she can't. She quickly learns she's trapped forever. She doesn't know her real name, and if she gets too stressed about these facts, she might turn into some kind of giant, formless, inhuman monster. And she's given the name Pomni by a weird flying tooth man. Pomni is stuck here, forever. She learns all of this very quickly, and very reasonably kind of has a mental breakdown about it. She tries to find any reason that this isn't real. It's a dream, maybe. Here's the important part. She was so terrified and shocked by the sudden revelation that she fails to acknowledge the people around her.
Thank you, Yagami, for following. Welcome. How are you doing today? My name is Brandon Bliss. I'm a variety streamer. I stream lots of video games to suggest me, as well as I draw art, and I do plan on doing 3D modeling eventually. I just don't have like the computing power to even do so right now. Well, welcome. I'm doing another art study, pretty much mastering poses while keeping anatomy consistent. I kind of already mastered the basics of anatomy. It's just like hands and feet, or like the nightmare scenario for beginner artists. What the fuck? I do. What the fuck? Here's a way to get rid of these lines. Jesus fucking Christ. Great. That's fucking great. Fucking restart this shit, because I don't know how to fucking... Oh, there we go. Turn off. Jesus Christ.
Pomni in episode 1 is self-serving. She is desperate and confused, which leads her to hurt or neglect others. Think about her interactions with the other circus members at this point. None of them feel personal. Like, compare that to those trademarked TADC therapy talks from later in the series, especially those with Pomni in it. The other characters seek to learn more about the people around them, who they are, what they want, what they're trying to get out of their actions. That doesn't happen in episode 1, and that's for a good reason, because Pomni doesn't care. Pomni doesn't want to know any of these people she's trapped with. She's only talking to them to figure out what is happening to her. And nowhere is this more clear than after Pomni escapes from an abstracted Kaufmo. After Pomni realizes she's safe, she begins to run away, but remembers that she left someone behind. She considers for a moment, almost leaving again, before turning back to check on Ragatha. Ragatha tells Pomni she's hurt and asks her to go find Kane so he can help her. Pomni agrees and begins to run around the circus calling for Kane, even getting hurt a bit in the process. Now, I know all of that doesn't sound very self-serving of her, but just bear with me here. While Pomni is running around looking for Kane and trying to avoid the abstraction, she sees her reflection for the first time since entering the circus. She sees what she's become. She sees who she's become. And I believe this is the moment it sinks in for her. This isn't a dream. She's really trapped here. And that terrifies her. She's desperate for a way to leave. Now, we learn in episode 8 that the circus characters are able to conjure things into existence. One example of this is Kinger creating a butterfly, which heals Ragatha and leaves behind these little particles. So, as Pomni is running around the circus, desperate for a way to leave, she suddenly sees an exit door that is leaving behind these little particles. While it's not technically confirmed that Pomni conjures this exit in this scene, it seems most likely that she did, and I think that thematically that works better. That makes more sense. So when Pomni sees this door, she has a choice to make. She can stay and keep trying to help Ragatha, or she can try to escape. And frankly, she does not hesitate. In my opinion, I don't think this was a conscious choice. I think Pomni was literally so desperate and terrified that she completely forgot about Ragatha. So Pomni chooses the promise of leaving over helping other people. And this is why I chose to describe Pilot Pomni as self-serving rather than selfish. I don't think Pilot Pomni is a bad person. I think she does care about other people, but she's also so terrified and confused that she doesn't have any room to worry for anyone or anything else besides her own anxieties. And, like, honestly, I don't blame her. She's in an insane situation. I would probably be crazy selfish and want to help myself, too, in her position. Pomni is completely overcome by her own fear and confusion. She runs through doors again and again, so desperate to leave that she cannot stop herself from going through the next one, because that what if rings in the back of her mind. What if this next one is the one that lets me free? So she keeps going. Empty office room after 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 empty office room, until she comes across a desktop and a headset. The exact same one she found, the one that trapped her here, seemingly less than an hour ago. She's confronted with the fact that she did this to herself. If only she hadn't put on that headset in the first place. If only she hadn't ever even entered that building. She continues to run through doors until she physically cannot, stuck in the void. Kane does rescue her and brings her back to the circus, and she sees Ragatha. She had completely forgotten about Ragatha until this moment. She sees how much pain Ragatha is in and has to face the fact that she in some way is responsible. She abandoned Ragatha, chasing after the exit. Ragatha doesn't even know that Pomni betrayed her, but Pomni does. Hi. Editing Artie here. I can't believe I didn't realize this while I was writing the script, but there's an even better example of Pomni abandoning Ragatha, and that's when she literally abandons Ragatha. Earlier in the episode, Ragatha is all glitched out because she got touched by the abstraction, and Pomni reaches out to help her, and then it makes her hand glitch. And instead of, it's probably painful for her, but Ragatha's literally on the ground, glitching to no end in extreme pain, and Pomni just got a little glitch on her hand, which scared her, so she completely ran away, leaving Ragatha behind, seemingly expecting the abstraction to stay with Ragatha, but it chases her anyways. Yeah, I don't know how I completely forgot about that while writing the script. That's my bad, because that's an even better example than the one I provided, but I guess that just gives more backing to my point. And that's what we learn about Pomni from the pilot. She's a normal person in a crazy situation that is so desperate to leave that she neglects to care for the people around her. That's where Pomni's arc begins. Now let's talk about episode 2. This episode literally opens with us seeing Pomni's worst nightmare. She wanders the circus alone, calling out for the others, but no one is there. She looks around to see that she has begun abstracting. She desperately yells for help, but the ground literally swallows her up and she plunges into the cellar. She sees the silhouettes of Cain, Ragatha, and Jax, who mock her, with Jax remarking that he can't even remember her name. This is interrupted by Ragatha knocking on Pomni's door to check on her. Throughout the episode, and honestly the first 3 episodes as a whole, Ragatha is trying to befriend Pomni, and Pomni doesn't really engage. Sure, she answers questions and goes along, but she doesn't really show Ragatha the same interest and curiosity that Ragatha shows her. And this applies to a lesser extent for all the circus members too. Pomni reluctantly joins Cain's adventure, seemingly not interested in getting involved at all. That is, until Jax literally throws her out of a moving truck. Pomni wants nothing to do with this, but through a series of shenanigans, she ends up below the map with one of the adventure's NPCs, 𝙂𝙚𝙣𝙚. 𝙂𝙚𝙣𝙚 realizes something about him is different from the players, and asks Pomni to tell him what's wrong with him. This conversation happens off screen, so we don't exactly know what was said, but Pomni tells him he is an NPC. What we do get to see is afterwards. Pomni realizes how unhappy 𝙂𝙚𝙣𝙚 is and asks to talk to him, telling him she doesn't want to just leave him below the map. When he tells her he doesn't matter because he's not real, she opens her mouth to say something very quickly, but doesn't. Instead, she just sits next to him. Then she tells him that she doesn't exactly understand, but she knows what it's like to feel like nothing. She tells him that caring about his friends matters, but he disagrees. He only exists to be an obstacle for the players. And she tells him he doesn't have to be. She invites him to join the circus with her. He asks her, would I even belong? And she tells him that he wouldn't belong any less than her, and that she could use a friend. And it works. 𝙂𝙚𝙣𝙚 agrees to join the circus. This conversation is Pomni's first real connection within the circus, her first friend in the circus. When she joined, she felt like her life didn't matter anymore, like she had basically died, but then she met someone who felt the same way, and she could see herself in him, and it made her realize something. If this NPC 𝙂𝙚𝙚𝙚 is able to feel, what stops him from being real? If Pomni can still feel, what stops her from being real? She knows who she is, and that is what makes her real, and this conversation with 𝙂𝙚𝙚𝙚 lets her realize that. So 𝙂𝙚𝙚𝙚 comes back with her to the circus. He's really excited. He looks around. He says, yeah, this place looks nice. I could get used to this. And then...
Looks like one of these guys made it through. Wait, what?
Wait, what?
Yeah. So then 𝙂𝙚𝙚𝙚𝙚 dies. And Pomni begins to panic again, because who can blame her? Maybe 𝙂𝙚𝙚𝙚𝙚 really was fake. Maybe he really never felt anything. So then what if she really never was real then? But before she's able to go too crazy, she's brought back to reality when she's invited to attend 𝙂𝙗𝙗's funeral. She sees Ragatha, 𝙂𝙚𝙚, Gangle, even Kinger mourning someone she never met. And she realizes her feelings, her love, her relationships are what make her real. They made 𝙂𝙚𝙚𝙚𝙚 real too. They made the people around her real. So whether or not 𝙂𝙚𝙚𝙚𝙚 is dead, their friendship, however short, was real. And she can have real friendships with these people too. She doesn't feel quite as alone anymore. And yes, this happens at 𝙂𝙗𝙗's funeral. She didn't know who 𝙂𝙗𝙗 was, but she can see the love that everyone around her had for him. She can see the relationships they had with him. And that's not something that can be made up by a computer. These are real people with real relationships. Who could possibly say that that isn't real? So that's her development in episode 2. In episode 3, Mystery of Mildenhall Manor, for the first, 2/3 of it, it's kind of just Pomni getting very, very scared by this weird horror game she accidentally fell into. But she's alongside Kinger. And when the worst of the horror is happening, Kinger literally shields her. He protects her as best he can before they are dragged down to hell. Kinger warns Pomni not to run through the Hall of the Damned, but she does anyways and literally gets possessed. Little side note, but I ordered the Pomni Animini's pendants when they first came out. I pre-ordered them. I had to wait like 3 months, and I was literally saying the whole time, oh, I want any of them except Possessed Pomni. I really don't want Possessed Pomni. She's so ugly. Any of the other ones I'd be so happy with. Guess which one I got? Guess which one I got, guys. Guys, guess which one I got? Guess which one I got, guys. Guys, guess. After she gets unpossessed, Pomni gasps and exclaims that she knew it would end up like this. She exclaims, "He just wants me to suffer," which is admittedly vague, but most likely is in reference to Kane. Kinger suggests that they take a moment to rest. Beaten, terrified, and exhausted, Pomni has nothing left to do but curl up and cry. Kinger apologizes for dragging Pomni down the horror route and explains how he is more lucid in the dark, and he reveals that he had a wife in the circus who had abstracted. He tells her that he understands how the circus can feel pointless, but having relationships with others gives it meaning. The only way to stay sane and happy in this world is to cherish your friendships. Pomni admits she's glad Kinger is here for her, and he reassures her that she is strong, and by holding on to her relationships with others, she can certainly get through this. They are able to escape the Hall of the Damned by holding their breath. Inspired by her conversation with Kinger, Pomni goes out of her way to express her appreciation towards Ragatha for always being there for her. This episode's development of Pomni builds upon and expands her lessons from episode 2. She learns the importance of maintaining relationships with the other circus members. She learns to find meaning in this new life by respecting, appreciating, and spending time with those around her. Episode 4, Fast Food Masquerade. So I actually work at a fast food restaurant in real life, and when my friends ask me about what it's like, I say it feels like being Pomni in episode 4, because I'm not having an especially bad time or anything, but like half the people around me are, and also sometimes I see someone I know outside of work, and that's really awkward. So anyways, at first glance, Pomni doesn't do a lot in episode 4, but what she does do is pretty interesting. While every other character has something to say about the proposed fast food adventure, Pomni and Ragatha both remain silent, only reacting to the people around them. That applies to Pomni most of this episode, honestly. I want to point out this little background moment where Pomni looks at the hole Zooble fell into and then looks at Ragatha and she just shrugs. I just thought it was cute. Also, Pomni is too short for the cash register, so she has to stand on a box. Look at her little face here. She's so adorable. Oh my god. And just look at the way she says hello to Gummy Goo.
Hello.
She just has a lot of really cute moments in this episode, and I wanted to point that out.
It does.
Gummy Goo? Yeah, so Gummy Goo is back. Pomni is obviously shocked by this and stumbles over her words when trying to ask if Gummy Goo remembers who she is. He acts as if he doesn't know her and is clearly put off by her odd behavior. Later, she abandons her register duty to crawl across the floor to go see him. Gummy Goo is clearly put off by Pomni's behavior and asks her if they know each other, to which Pomni responds, "I don't know." When Gangle confronts Pomni for abandoning her post, Pomni replies, "But it's Gummy Goo. Can't the job just wait a bit? It's not like any of this is real." Gummy Goo is visibly surprised by Pomni knowing his name and opens his mouth and reaches his hand forward as if he wanted to say something, but he's interrupted by Gangle having an identity crisis. Presumably, Gangle herds Pomni away from Gummy Goo and back to the register. Pomni obviously was both shocked and excited to see her first friend in the circus, a friend she saw die, mind you, back again and right in front of her, only to be greatly disappointed when she realized he didn't remember her. Now, I do have my own theories about Gummy Goo actually remembering her, but for the sake of this conversation, that's not really relevant. From Pomni's perspective, Gummy Goo does not remember her. Later, when Gummy Goo and her friends begin to leave, Pomni abandons post once again in the middle of an order to go see him one more time before he leaves. Pomni begins to start speaking to Gummy Goo, and while we don't know exactly what she was going to say, it's pretty safe to imagine she was going to try and remind Gummy Goo who she was. But then she sees his face. He looks distraught. Pomni has a decision here. She could either tell Gummy Goo who she is and what they went through together, potentially jogging his memory and rekindling their friendship, or she could let him go. Option A would bring back her dead friend, something she obviously wants, but it would also hurt Gummy Goo, learning that he's an NPC all over again, and that he's so disposable that he was already killed, brought back, and likely will be killed again, just for the players to have a character to interact with in whatever game they're playing. Option B would be letting her first friend in the circus leave her all over again, but it would spare him that pain. Pomni takes a moment to think before giving him a kind yet generic fast food hospitality farewell, and as 𝙂𝙗𝙖 walks away, she stares sadly after him, and then at the ground. This is the very first test of Pomni's development. She can either be self-serving by reminding 𝙂𝙗𝙖 who she is, or self-sacrificial by letting him go. And she chooses to let him go. This test fittingly takes place in episode 4, which is between the beginning of her arc, episode 1, and the end of her arc, episode 8. We are now beginning to see the person Pomni is going to become. She's going to become a person who is willing to give up her own wants and desires if it could benefit others. Later in this episode, Pomni witnesses 𝙂𝙠l step outside, take off her plastic mask, and scream into her palms. She asks 𝙂𝙠l if she's okay, encourages her to talk about, quote, her issues, unquote, with Ragatha. 𝙂𝙠l says she loves Ragatha, but it's sometimes difficult to tell how genuine she is. Pomni tries to continue the conversation, but 𝙂𝙠l interrupts her, puts her plastic mask back on, and leaves. Pomni is left feeling disappointed. She genuinely wanted to help 𝙂𝙠l, but approached it as, quote, another one of these, end quote. A therapy session she was facilitating rather than a genuine conversation with a friend. But Pomni isn't done trying to help. When she sees 𝙂𝙠l later that night, tired, dreading spending another moment at the restaurant, Pomni offers to stay behind and close for her. It's a small gesture, but it was exactly what 𝙂𝙠l needed at that moment. She needed someone to see her.
Okay, so basically I'm drawing my OC again. Pretty much. I'm playing around with some aspects of my OC, see if I can improve on it and stuff like that. I'm also trying to improve on mastering poses and anatomy. We're pretty much doing a 1-2 combo. I realized I completely forgot to do like ears. So let me do that a bit. I'm gonna have to pretty much this portion. All right. But yeah, pretty much I'm trying to just improve on, and I decided, because just making the new random OCs each time and just want to improve on stuff like that, like on the basics is pretty much it takes extra. To me, it'll take extra. In computer terms, it'll take more processing power than what I necessarily need to use. So pretty much, if I just draw my OC, pretty much, if I just keep drawing my OC, I won't have to worry about like the details of, oh, what's this gonna be like? What's that gonna be like that? I already know. I already have it planned out. So pretty much, I can spend more time on making stuff like just improving on my foundation overall. Pretty much. But yeah, I figured that's the best method for me to do. Like take one OC and then use that OC to practice, just practice drawing in general. But yeah. Yeah, I'm just primarily focusing on just working on this. I already like posted one other finished art study beforehand. But yeah. How long it's been since you decided to commit to our journey? Okay, so for me, it was since 2018. Since 2018, I decided to commit to my art journey. But overall, I've been drawing since I was like 3 years old. Yeah. My parents were wrong about being the next Picasso, but they didn't expect me to be an anime Picasso, sorry. Brain is not braining right now. Jesus Christ. But yeah, in fun fact, I've recently dug up like I used to be in a pretty much a IEP program for learning disabilities, and I pulled out one of the my IEP reports from my filing bin. So this is back in like this report was back in 2008. So basically, what I said was pretty much, I want to be an artist when I grow up, and I'm an artist. I said, fuck it, might as well, try to at least fulfill my childhood dreams. Do what you gotta do, you know? And honestly, nowadays, having a practical job, sure, it's good to have like a stable source of income, but also what I was originally planning to do is like keep my corporate job while trying to build my career being a VTuber. But ultimately, corporate job didn't pan out well, but mostly because of many, many unfortunate life circumstances. But that's a story for another time. But yeah, I'm pretty content with where I am now. Sure, not really making any money, but just relaxing. Good. It's a shame. I hear you're doing better. Yeah, I'm doing better now. As you probably have seen on my Twitter, Blue Sky. I recently lost my car. Car got totaled. Recently lost my job. But I'm doing what I can. Well, pretty much I'm doing what I have to do. Alright, there we go. I kind of want to do something this. Okay, then... Alright, that looks more natural. Rather fair. Alright. Yeah. I'll try and stay till the end stream. Like how I do Zaya. Aw, thank you. Honestly, I keep on missing Zaya streams. I keep on missing the chance to raid Zaya, pretty much. But yeah. I'm just doing what I can and enjoying the best I can. Okay, ahead. I'm gonna try to Simpler the better. Alright. Oh yeah, I usually play a YouTube video while I'm drawing. I have started learning how to draw recently. Ooh, what are you using? Like a art book? Cause that's what I started with when. Thank you to Opal for following. Well, welcome. How are you doing today? My name is Rainbow. I'm a variety streamer. I stream lots of vegan chat as well as I draw art, and hopefully I'll be doing 3D modeling for everyone here. As I was saying, what do you use to start your use an art book, art pen. Oh, there we go. Because I started with a art book. It was a basic anime tutorial. It did the job, but like it didn't really work out for me. Right now, I'm just me, iPad 9th gen, 2021 first. Ooh. Oh, sketch wizard. Nice. I started out with pencil, markers, and like my own sketchbook, pretty much. I had 3 sketchbooks, 3 whole sketchbooks. Unfortunately, I lost the sketchbooks, but luckily I had the foresight to take pictures of it and back it up on and back those photos up. So I still have like my sketchbook digitized. But yeah, I occasionally draw on paper from time to time. But I'm more of a digital artist because of all the all the features for it. Plus, my art tablet that I have right now is an XP Innovator XP Pen Innovator 16. I bought back in 2021. I didn't have like any like use for it, like actual use for it, until like I was hoping to get like a PC, and I did. I got a PC back in back last year, but I wasn't really like deep into digital art yet because I was still doing traditional art. And then when I think it was about 6 months ago, I think pretty much taking like digital art courses, getting all the basics in. I chose Fire Alpaca because it's free, like the actual like free one on the website. But as soon as I heard Fire Alpaca was selling a pro version on Steam, I immediately bought it, even though it's $40, which is a lot cheaper than most professional programs. It's not as jam-packed as like say Clip Studio EX, but it's more than enough to learn off of and pretty much get everything done. But yeah, I also like I think it was 2 weeks ago I found pretty much like someone on Etsy was selling their pretty much a study guide, art study guide, like art study guide $7, let me buy it. That was I think it's 2 or 3 years. I think it's 4. How much was it? Oh no, sorry, it was 2 months ago. Sorry about that. But pretty much their art study guide is fucking phenomenal. Because I didn't start like using the study guide until pretty much last week. It's phenomenal, and here's the thing with me. I used to do the skeleton method, saying, oh, this, and that. But, I think I watched a YouTube video about, like the silhouette method, going from like trying to trace a drawing, but like, you know how like in your art, like original like art classes, and you say, "Oh, you see that here's a fruit. Draw it without looking at the paper." So pretty much, I got back to drawing without looking at the paper. It works better. I can't tell you how much it works better for me. Like, I used to suck at it back when I was first initially was taught it, but nowadays I understand now, and yeah, with digital art, it just makes it so much easier. Glad you found a method that's providing better results. Yeah, plus I'm not entirely relying on tracing, as my mindset is, oh, this is how the artists do it. I'm going to see it pretty much try to trace back how they did it and why they did it. And that's what I've been doing. Not necessarily tracing, but trace backing, I guess. I don't know where I was going with that. But yeah, I do hope, like, I do wish you well on your art journey. And I do hope you find a method that works for you. Alright, Scythe. Oh, you're welcome. Okay. It's more of... God. I can look up some sites and see what I can use. Yeah.
How she really felt, and offer her genuine help and support, not just platitudes and advice. Here, Pomni learns a small but important lesson, one that'll come up later. Help and care isn't always having little DIY therapy sessions and talking about feelings. Sometimes it's quiet. Seeing that someone isn't okay doesn't mean you have to press them to talk about it. Sometimes you just need to be there for them and offer what you can. And we see how much this affects Gangle. Shortly after episode 4 premiered, Glitch released this image. Gangle drew herself and the people who helped her most when she needed it. She drew 𝙂𝙚, of course. We already know that those two are, really good friends.
Really good friends.
But she also drew Pomni. This small gesture from Pomni made such a big impact on Gangle that she now sees her as one of her 2 closest friends in the circus. Mind you, Pomni has only been in the circus for like a week max at this point. Pomni in this episode is tested on her development and self-sacrifice, and she learns to offer support to those around her through her actions, even when she can't support them through her words. One thing I want to emphasize is that Pomni becoming less self-serving doesn't mean she needs to become a people-pleaser, accepting anything from anyone. As we clearly see within TADC's writing with Ragatha, that is an issue in and of itself. Pomni's development is about putting her respect and love for others above her own personal desires, which is not the same as people-pleasing, which stems from a desire to be liked. As we see in episode 5, Untitled, Pomni is not afraid to be blunt, sarcastic, or rude if the situation calls for it, and that has nothing to do with her character development. If anything, the closer she gets with other characters and the less self-serving she becomes, the more blunt, sarcastic, and rude she gets, at least compared to the writhing ball of anxiety that is Pomni in the pilot. In episode 5, Pomni is, as usual, not very interested in the adventures, but we do see her taking advantage of any opportunity she can to grow close to the others, and we especially see her develop a friendship with Jax in this episode. It's notable that while she and Jax do get closer in this episode, she never defends his unkindness towards the others. We don't see her reaction to him shooting and chewing the Gangle rhino, but she does vote yes to make him a vegan afterwards, implying she found it distasteful. During the President Pomni section, all the characters seem very willing to accept her authority, except Jax, obviously, though he was the one to suggest the adventure. This will be relevant in a discussion of a later episode. When Jax tries to buddy up with Pomni by gossiping
there
about
we go.
Gangle to her, she is quick to remind Jax that he threw her out of a moving truck.
Have fun drawing.
She might not hate him as much as 𝙂𝙚, 𝙂𝙚, or Gangle do, but she's also not willing to be won over by Jax the way most people in this fandom are. During the stargazing adventure, Pomni expresses relief that there's finally an adventure where she can just relax. She's quick to defend Gangle and 𝙂𝙗 when Jax speaks unkindly about them, but doesn't outright shut him down. She wants to get close to the people around her, including Jax. When she learns that there's some mysterious backstory related to Jax and some unnamed
Alander
friends,
or
she doesn't
Zombra.
push him to talk
Thank you,
about it.
Zombra, for following.
She asks
Welcome.
once, gets brushed off,
How are you
and moves on.
doing?
Pomni surprises
I'm
when
currently
Jax
doing the
apologizes for
art
the
study.
adventure, seemingly shocked that Jax is
I'm currently doing an art study, making sure pretty much I properly learn how to pose characters, how to envision poses, and making sure anatomy is consistent.
capable of apologizing. Pomni reluctantly forgives Jax despite 𝙂𝙗's warning to ignore him. Jax immediately takes advantage of this to brag about his budding friendship with Pomni to 𝙂𝙗. When a vote is called by Gangle to put Jax in a maid outfit, Pomni actually votes against it, despite the fact that it came immediately after Jax insulting 𝙂𝙗. This is unrelated, but you can also see that Kinger voted yes to maid Jax. I assume he was unaware of what was happening, but I really don't know. I just felt the need to point this out because it was funny, and I don't think I've ever seen anyone else point it out. But that's a little irrelevant. During Pomni's turn to bat, she offers 𝙂𝙗 her turn. While we learn later that Pomni doesn't like sports, this is still a kind gesture when she wasn't able to console 𝙂𝙗 with words alone. We see Pomni using that lesson she learned last episode. Additionally, the softball episode introduces Evil Pomni, one of my favorite side characters, which gives us an interesting angle to look at Pomni from. Evil Pomni is simply opposite Pomni, or at least to some degree she is. So let's take a look at who Pomni isn't, so we can get a better look at who Pomni is. Evil Pomni is crass, bold, has bad posture, and is quick to insult others. We can compare these traits to real Pomni, who only curses when under high stress, is meek, has straight posture, and treats others kindly. Pomni grows close with Jax this episode, yes, but she's also kind of treated like an only child in a divorce where both parents were trying to be the favorite to spite each other. We see her making an effort to grow close to others and using the lessons she learned last episode, but we don't see much development from her personally. Episode 6, They All Get Guns, opens right about where the last one left off.
Ooh.
Pomni and Jax are hanging out.
Thank you, Sonoma, for following. Welcome.
In their interaction, we see
How are you doing today? Welcome. We're doing art study here, mostly about posture and anatomy. I want to pretty much improve on it so badly at this point because even like I don't know for a number of years, but pretty much my proportions were off, and pretty much I just wanted to find a way to actually figure it out. So I'm pretty much using a art reference book, pretty much a art reference packet I bought off of Etsy, and it's actually really good.
more of the same patterns from the last episode. Jax is a jerk to 𝙂𝙗, and Pomni doesn't really say anything about it. When it was announced that they'd be having a duo adventure, Pomni sought out 𝙂𝙗 first, which actually makes a lot of sense. Despite what 𝙂𝙗 might believe at this point, she is kind of Pomni's closest friend in the circus. Gangle and 𝙂𝙗 were already paired, Kinger is Kinger,
I kind
and
of
despite
like
their
that.
growing friendship, Pomni is aware of how cruel Jax can be. Meanwhile, Pomni and 𝙂𝙗 are both just genuinely kind people who enjoy each other's company. But 𝙂𝙗 points out that it's not a good idea for Kinger and Jax to be on each other's team, as Jax would likely torment Kinger, so Pomni is paired with Jax instead. The two grow even closer during their time together. While Pomni isn't really sold on Jax's "we're all just cartoon character archetypes"
I mean, for me, the best way to draw an enemy is a shapes method. Fair. Kind of like, for me, the shapes method, I did the shapes method before. For me, it's kind of like a creative geometry for me. Or the geometric aesthetic. Or modern, just modern art. But yeah. I mean, the Shapes method, it is very good for beginner artists. If you're just starting out, you gotta do the shapes method first. It'll get you a good feel of what you like, what you don't like, stuff like that. For me, it's like onion, which has layers. Or pretty much like you learn how the skeleton works, then you learn how muscles work, and then pretty much you learn how people are supposed to look, how light affects, the light angle affects shading, how people are presented. But yeah, it's like starting from the inside out. I guess you can compare it to like using those wooden dolls, composing wooden dolls to figure out how to draw, which is also good.
She's willing to play along for a little bit for the sake of playing what's essentially paintball with her friends. She even learned something about the circus from Jax. She's able to influence the outcomes of events through sheer will. We see this when she's able to shoot better by being confident and cartoony than when she was actually trying, as well as the insane trick shot she uses to take down 𝙂𝙚𝙣𝙚. Now, we know since episode 8 that this is from the Conjuring thing that Kinger mentioned, but at the time it was a new concept. I'm going to take a little detour here to point something out. Pomni doesn't really like physical touch. We know this because Goose states it outright on Tumblr, but we can also see this in text from Pomni's body language, and when other people touch her or almost touch her.
Off we go!
Dollface, I've got a key to his room.
Wait, what? Jump scares that well?
Come on, that wasn't even scary. What? You scared of the vacuum cleaner too?
Hey, be nice to her.
Wow, the first steps of a budding friendship. Right, Ragatha?
I don't really...
Since you're new around here, we're gonna make it a simple in-house adventure!
Pomni is so excited by the fact that she and Jax won that she hugs him. The character who constantly avoids and flinches away from physical contact gives someone a hug, and he pushes her away. And then you guys know what happens. Now, many other people who are much smarter than me have analyzed this scene and broken down every tiny detail, and this is an analysis of Pomni's character development, not of Pomni and Jax's relationship, so I'll keep this brief. Jax both literally and figuratively pushes Pomni away from him, insisting that he is nothing but a bad person who bullies others for fun because acknowledging that he truly hurts people is too painful for him. And Pomni completely sees through this act, but she's also seen the lengths he's willing to go to keep it up. So what does Pomni's relationship with Jax teach her? Pomni learns that some people won't accept help or love, that no matter how hard you push to become close to someone, it's ultimately up to them to receive it, and sometimes they simply won't. Pomni learns to give space to those who cannot accept others growing close, but never leave them alone. Think of Kinger's speech in this episode.
The way I see it, relationships are two-sided, and sometimes it doesn't make sense to do all the heavy lifting when the other isn't in the mood. We all go through and deal with things differently, and sometimes you just need to let people do things their own way, as long as you're still there when they need you. Giving someone space should never be the same as giving up on them.
Not only does it apply to Ragatha, it also is what Pomni learns from Jax. She learns to love from afar, never letting go of Jax completely but allowing him to refuse her friendship. Episode 7, Beach Episode, lets us see so much from Pomni. For the first section of this episode, it's emphasized how close Pomni has grown to the other circus members, especially Gangle, Ragatha, and 𝙂𝙚𝙣𝙚, but we see her playing with Kinger too. Learning from last episode, Pomni is giving Jax some space. Pomni is enjoying her time at the beach until she sees an NPC mannequin hiding in the bushes and beckoning her towards him. She actually saw this mannequin before in episode 5, but here is her first opportunity to actually interact with him. We don't get to see their conversation on the screen, but as far as we can tell, he told Pomni he was a human like her, or at least not an NPC, and that he has a plan to leave the circus. But in order to tell her, they must be away from Kane's prying eyes and the Chinese room. Either Ragatha, 𝙂𝙂𝙣, and Gangle were with Pomni when this happened, or she filled them in afterwards. At some point, someone suggests that they go find Jax and ask for his help entering the Chinese room. When the Chinese room is open, Pomni goes to get Kinger, but Abel stops her, telling her that they can fill him in later. His excuse is that he and Kinger have a history that Abel isn't ready to face yet. Pomni is hesitant to leave him out, but ultimately doesn't argue. Here's where we see the beginning of Pomni's character regression. It's subtle, but it is there. Pomni's interactions with Abel in this episode consistently look something like this, and please ignore my poor attempts at character voices. I know a way out of the circus. I'd I'd love a way out. Let me include my friends, too. You cannot include one of your friends. But I'd really like to. You can't. Okay. Throughout this episode, especially in conversations with Ragatha and Pomni, Kinger's wisdom and trustworthiness is constantly brought up. It's clear the two really care about him and don't like leaving him out. When Abel insists that leaving Kinger out of the plans is good, Ragatha and Pomni do push back. They tell Abel he needs to tell them what's going on, but he dodges the question and they don't push any further. When Abel and Kinger do finally see each other, nothing really happens. Kinger makes no remark about Abel being there, and Abel doesn't really react to Kinger. Jax is hesitant about entering Kane's office, but he's easily reassured by Pomni, who doesn't hesitate to try and comfort him. When all the characters join hands to walk down the final hallway, she offers a hand to Jax, one last offering of friendship before they leave the circus, and he refuses. Pomni is given a simple choice when she sees the console. Press the red button or the blue button. Stay or leave. And she doesn't press anything. The other players urge her to press the escape button, seemingly unspokenly agreeing that she should represent them. This is one of the biggest signs of her development. Pomni in the pilot, even from the first few episodes, would have pressed the button right away, no hesitation. She checks what Kinger thinks, but before the circus members are able to come to a unanimous decision, Jack slams the red button, and it's revealed that all of this was an adventure. Pomni in this episode is tested once again. She's offered the promise of escape, but she has to exclude Kinger to reach it. And she does, repeatedly, until the very end. She tries to reach out, but it's too late, and she realizes her mistake. If Pomni had included Kinger from the very beginning, she likely would have found out the adventure was fake sooner, but instead she let the promise of potentially escaping lead her away from what she knew was right. And finally, episode 8, 𝙂𝙚𝙣𝙚, lets us see Pomni acting with all the lessons she's learned. She tells all the cast members to give up hope of leaving the circus and to instead focus on supporting each other. This is her development in her own words. She had to give up chasing her own desires, escaping the circus, to focus on what she really needs, loving and supporting others. But she needs to show this in more ways than just words, and she does just that. When Kinger devises a plan to stop Kane from tormenting the players, it requires Pomni to find him a computer, and she knows just where to look. And here we have a beautiful parallel to that first exit door scene. This is the scene that inspired this entire video, a perfect chance to compare Pilot Pomni and Pomni at the end of her arc. Pomni returns to where she first saw the mirror. She stares at who she's become familiar with, the new her. This could lead her to spiral again, but she shakes away any doubt or fear. She doesn't have time to waste worrying about her situation. Her friends need her. She closes her eyes and summons the exit door again, no longer fueled by desperation or confusion, but self-assured and determined to help her friends. And the door appears. The scene of Pomni running through the C&A office is nearly a shot-for-shot remake of the scene from the pilot. The only real difference is her body language. While Pomni in the pilot was terrified and driven by a need to escape, running wildly with desperation, Episode 8 Pomni walks with a calm and determined speed, motivated by a desire to help her friends. She's no longer anxious and hyperventilating, but steadfast and a bit annoyed by the long walk. When she finally comes to the desktop, she considers the headset briefly. While there's no way to know what she was thinking, I imagine she was thinking about putting it on. What if it set her free? What if? But the circus starts to shake, and she's reminded of her friends who are in danger. She doesn't have time for what-ifs. She picks up the desktop and leaves. She won't let what-ifs rule her life anymore. She needs to help her friends. When Kinger is coding, it is vital to keep Kane distracted. If he checks on Kinger, the entire plan could fall apart, and he almost does just that. But Pomni steps in. She insults Kane in the way she knows will hurt him most. The same Kane who's been torturing her endlessly. She makes him angrier than he's ever been and put herself directly in harm's way to save Kinger. All of this comes to a head when Kane is deleted. The players fall to the ground, look at where Kane was, and then they all look at Pomni. When I first noticed this, I couldn't unsee it. And it's everywhere. It's in episode 7 when the others expect her to press the button on their behalves. It's in episode 5 when they all accept her authority as president. Pomni connects all of them together. No one thought of Kinger as anything but a crazy old man until Pomni got there. No one expected Ragatha to show genuine non-people-pleaser kindness until Pomni arrived. No one had managed to get as close to Jax since Ribbit's abstraction as Pomni did. No one truly offered Gangle the help she needed until Pomni did. Pomni is trusted by everyone in the circus. because she learned to reach out and make connections more than seek her own escape. She became their unofficial leader. She became the heart of the circus. And until episode 9 releases in June, that's where we end. So if Pomni's character development is so expertly written, then why doesn't anyone talk about it? Because it's so expertly written. Pomni isn't seeking lessons in friendship and writing letters to Princess Celestia. She's experiencing the world around her, slowly learning more and more the more time she spends, just like the audience. We see the digital circus through Pomni's eyes and grow alongside her as we watch the series. We go from seeing the people around Pomni as mere silly cartoon characters in the pilot, before growing to see them for who they are, building connections with them, and feeling every hit against them as if they're our own, exactly as Pomni does. Pomni has gone from self-serving, neglecting the needs of those around her for the fleeting promise of an exit, to actively putting herself in harm's way for a chance to save her friends. She has become beloved by those around her, whether they'll admit it or not. Pomni has proven herself to be kind, brave, strong, empathetic, and generous. So what does any of this mean for episode 9? What can we expect from a circus that no longer has a ringmaster? While there's no way of knowing for sure, I expect we'll see everyone looking to Pomni for answers, and she'll have to deal with the responsibility of being the unofficial leader of the circus now that Kane is gone. In the wise words of my favorite jester, well, it's possible.
Aww.
I want to thank everyone who's watched. I know that sounds corny, that's what all the YouTubers say, but
This scene is not supposed to be rendered on Nintendo 64.
It was a nice video. I do agree, and it was well articulated too. Honestly. We all agree with Pomni having a similar opinion to her.
The textures are all rendered at 256 by 256, even though the Nintendo 64 can only load full color textures up to 32 by 64 into its texture memory. This should be impossible. Just like how you've probably never seen normal maps and roughness textures rendered on the Nintendo 64. But these all work and even perform well on real hardware. Let me explain. When the Nintendo 64 was created, computers were significantly weaker than they are nowadays. Consequently, a cost-effective real-time rendering machine, such as the whole idea of how a scene is supposed to be rendered for the software developers. Things like vertex colors, texture filtering, UV mapping, and triangle rendering, even texture formats, all had special hardware parts to support their functionality, and you needed to render in a specific way to make use of the support. That means that doing 3D rendering using this intended path is fast and convenient. It is rare that a game would want to wander off the proven path. It also means that rendering is fairly limited. No programmable shaders, a hard limit of 4 kilobytes of texture cache, and even those 4 kilobytes have to be accessed in a limiting manner that makes some texture setups impossible. And it is just the tip of the iceberg. But human ingenuity combined with time is sure to find ways to bend the rules to make a new path. And despite it not being officially recommended, we find that sometimes doing things in weird ways offers unique benefits, and those weird ideas is what we will look at today. After all, efficient code is almost never intuitively understood. Before we can understand how breaking the intended path can benefit us, we have to understand what the intended path even is. The intended path is simple. First, the CPU prepares something called a display list. This is a long list of commands that set up the camera view, places mesh transforming matrix commands, and triangle, texture, lighting, material, and vertex commands alongside some other render properties. This list gets sent off to the RSP, which then processes this list via a thing called microcode. Microcode is provided by the game and can be customized to fit your needs, although in practice most studios barely touched it. Microcode is a micro-sized code file that contains special assembly instructions designed to be fast at computing 3D geometry. The RSP's instructions can process a vector with up to 8 components, letting you do 8 computations at once with just a single instruction. perfect for processing many triangles vertices all at once. This microcode doesn't render any output pixels, but it does determine all the triangle equations that decide how textures or colors will be mapped onto the triangle and other miscellaneous render comments for the RDP. The RDP comments are all set in stone. These are all handled by the special hardware parts. Rendering the triangle commands into pixels is the most expensive part, so it makes sense to let special hardware handle it. Even then, it is the slowest process by far. The RDP outputs pixel color and some anti-aliasing into the frame buffer. It also writes the triangle depth values into the depth buffer and tests against the depth buffer for triangle drawing. Afterwards, the frame buffer can optionally be written to by the CPU or the RSP again to do post-processing. Or you could even set up a display list command to read from the frame buffer to feed info back to the RSP or RDP and repeat from previous steps. And then the final step. The video interface takes the frame buffer, applies anti-aliasing and other VI effects such as de-dither, pixel sizes or even blur, and then ships the output off to your TV. Alright. Seems like a lot of work, but software is complex and it needs us to allow all kinds of effects, so this kind of makes sense. Let's start off with some simple ways to disrupt this rendering flow to get new effects, just so you can understand what I want this video to be about. First, right here when we set up the render material, there is nothing preventing us from using any arbitrary piece of data loaded into RAM as a texture. For example, random code or data. You can actually see this exact effect on the GameCube game Metroid Prime, so this isn't even an N64 exclusive trick, but it is especially easy and valuable to pull off on the N64 due to the low amount of memory we have available. This trick is actually also, possibly unintentionally, used in the N64 Zeldas for the Deku Stick. They have an 8x8 texture for the stick, but load a 16x16 sized chunk, leading to other data being read as the texture. It looks great though. This is actually also the reason the Deku Stick looks different in Majora's Mask. The data it's pointing to has changed. The next trick is one I use excessively, and nowadays our modding tools have native support for it. It lets us skin models so we don't need to make those N64 style limp sausages. You see how someone stole his kneecaps and took a bite out of his elbow? When we send the matrix, vertex and triangle command to the RSP, there's nothing stopping us from instead sending two matrices for just one batch of triangle commands. So what's the benefit of that? Well, we can load half the vertex buffer with matrix 1 active and the other half with matrix 2 active. This is supported simply as a side effect of how microcodes are typically implemented and was even possible in Mario 64. In fact, I did just this with a hex editor a long time ago on an unmodified Mario 64 ROM to show it is possible. Using this trick, we can make triangles deform along animations and get connected, animated limbs almost entirely free of processing costs. This also saves you a ton of triangles, so it is a tragedy this technique took so long to adopt. Not having to close off limbs as they had in most N64 games would have freed up a serious amount of triangles. 30 extra triangles would have gone a long way in a game like Mario Party. Fortunately, they did seem to have this figured out for Smash Bros. 64. There's actually another cool trick at the texture loading stage. There's nothing stopping us from rendering directly onto a texture. This lets us implement a modern rendering pipeline for a surface, render the output over a texture, and get properties like normal maps or metallic maps. I've done that right here for this Mario Odyssey-esque coin, and it runs full frame rate on a real N64. Obviously, this would be very expensive to render for thousands of pixels still, but there's one very cool simplification we can make. Palette textures. With a palette of 256 or even just 16 pixels, we would only need to run the PBR pipeline on these few pixels and they get a decent looking and very cheap output. Doriel has shown me this cool usage of that technique and it looks awesome, plus it costs basically nothing. This technique is actually cheap enough to a point where you can realistically use it across a whole game to get an entirely modern rendered looking video game on the Nintendo 64, provided you don't need smooth shading anywhere. This would limit you to exclusively man-made angular structures, but it would be insanely cool to see. Another trick is right here, where it computes the color. There are a couple bugs or properties The line between the two is blurry, that emerged from the combiner, and there's actually so many that I have an entire video dedicated to this. You should watch that too. You can do some cool stuff like bloom, these cotton candy-esque materials, or even Mario Galaxy's appearing past. When the RDP outputs a pixel to the frame buffer at this step, it outputs it in RGBA 16 format across 2 bytes. This format has 5 bits per color channel and 1 bit for alpha. But there is no such thing as transparent video output. So really there's only 15 bit of color information and 1 extra bit. In addition to this extra bit, the N64 actually has a hidden 9th bit in every byte that is used by the render output as well. These 3 extra bits are used by the RDP by outputting a coverage value that is later used to apply anti-aliasing, which blends triangles with less of a staircase pattern. But you can absolutely disable the anti-aliasing in the video interface and instead use those 3 bits to mark special properties similar to a modern stencil buffer. The most straightforward example of this technique I've ever seen comes from 𝙂𝙚𝙣𝙚𝙧𝙖 water effect. The water material itself sets these special bits to the correct value to mark the rendered 2 pixels. He can then identify which pixels were tagged by the water material and shift them around in a wave-like motion. A much more contrived example of this is Majora's Mask's Lens of Truth. Majora's Mask specifically, Ocarina of Times, is much simpler. It does some magic. Much too complicated to be part of this video to ensure transparent geometry plays nice with the lens effect that manipulates the coverage values. Let me know if you'd like a separate video dedicated to that, because it really would have to be a full video. Of course, you can also use your coverage values as a stencil for any kind of other effects you would like. It is actually possible to read the hidden bits with the CPU on the Nintendo 64, although this is such a crazy feature that no emulator, not even analog 3D's FPGA, implements this behavior yet. It's also very expensive because reading the hidden bits is not cheap, so who knows if anyone will ever make use of this. A simple effect, hacking with the depth buffers, can be seen here with Patchmaker's Workshop's portals. Simply render a scene once, then clear the dead buffer only in the small part, and fill it everywhere else with the closest value, and then render the scene a second time. This will cause the second scene to only render in the small square, which gives you this cool portal effect. Well, at least that's one easy way to do it. I don't actually know if this is exactly what he did. Maybe with the help of the tricks from this video, you can think of a cheaper way of doing it. There's actually even more hackery to the RDP step. I need to ask you, what is a triangle? I know it sounds like a stupid question, but it is an important one. Typically, you would say it is the shape made by connecting 3 dots. But 3 dots is not practical to work with. That's why the RDP has its own format to describe what a triangle is, which consists of mathematical formulas. These formulas let the RDP evaluate triangles much quicker than it ever could by supplying a set of points. This format can represent triangles, but it can also represent some less identifiable shapes. All these shapes shown here are valid RDP triangles. Usually RDP triangles are computed by the microcode, but there is technically nothing stopping you from just making an abomination yourself. RDP triangles come in many shapes and forms. You can do this, for example, to draw a quad with just 1 triangle. And in fact, internally, the UI rectangle command and the F3D microcode family are making use of this. But by manually making one, you can supply things like vertex colors to the rectangle, which is typically not possible on official Nintendo microcode. 𝙂𝙚𝙣𝙚𝙧𝙖, who recently finished the Banjo-Kazooie recompilation, let me know that apparently GoldenEye uses this for its guy. Very cool. This technique would be perfect for Mario 64's Gradient Hunt too, and would save you a lot of texture memory. You can also insert render checks after the frame buffer is rendered, or even feed the frame buffer back into the render and jump to an earlier point into the pipeline. The coolest example of this is probably what 𝙂𝙚𝙣𝙚𝙧𝙖 has been doing, since you can run any logic you want on these pixels here. You can also pull off any effect you want. 𝙂𝙚𝙣𝙚𝙧𝙖 has examples like HDR rendering or even bloom. Of course, these are very expensive effects, but the result is worth it. There is one kind of weird render hack you can do on the VI to increase image clarity. See, usually the Nintendo 64 comes with a horizontal blur you're not supposed to be able to turn off. It blurs pixels horizontally to upscale the output image. A 320 by 240 rendered image actually gets output as a 640 by 240, with every other pixel being a blur of the two neighboring pixels. For the longest time, I did not know of a way to turn it off, and I didn't even know it existed. But the homebrew community pointed this out to me, and there's a funny way of turning it off. You simply provide a slightly wrong frame buffer scale to the VI, and the blurring algorithm ends up working out to no longer blur pixels. We did basically nothing at all, and it instantly looks so much sharper. There's one more thing I want to bring up, and I teased this in the beginning, because it basically turns the entire rendering pipeline upside down. And that is Hail to Dodongo's high resolution rendering pipeline. He figured out a way to modify this rendering pipeline to render much higher resolution textures. He implemented this with 256 by 256 textures in full color format, which is 32 times higher than the Nintendo 64 usually can do. Look at that insane difference. And the craziest part is that the actual final output is basically entirely drawn without the RDP. The way he explained it is actually awesome and much simpler than you would think. He simply has the RDP draw colored gradients instead of textures into a frame buffer. And then he uses the color values of the pixels that were drawn as X and Y coordinates for a texture to look up a pixel from. He can index into multiple textures, for example by storing the texture ID into the red channel, and the X coordinate into the blue channel, and the Y coordinate into the green channel. He simply iterates all pixels to generate a whole new image based off the first rendered buffer. This does have the disadvantage that it adds an additional constant cost to the render, of course, but man, this effect definitely has a use case, and seeing a full game take advantage of this would be so cool.
Yes, I am big into tech. Honestly, I kind of stuck in between wanting to go into psychology and wanting to go to cybersecurity. Well, more so of like just studying cybersecurity. I want to have a deeper understanding of it. I want to have a deeper understanding of psychology as well. Plus, those two go hand in hand.
So Apple has been exposed for using your YouTube videos to train their AI, and now they're going to have to pay for it, literally. 3 YouTubers are actually suing Apple for using their videos without their consent, them being 𝙂𝙚 Productions, also known as 𝙂𝙚𝙣𝙚, I'm sure a lot of you guys know him, Mr. Short Game Golf, and 𝙂𝙚𝙣𝙀𝙧, and they're suing Apple over claims that the iPhone maker scraped videos without permission to train its AI models. The class action lawsuit claims Apple violated the DMCA when it unlawfully circumvented YouTube's protections to scrape millions of copyrighted videos for AI training purposes. The claim is based on an academic paper published by Apple researchers that states the company used a dataset called Panda70M. It contains millions of illegally obtained high-quality YouTube videos split into 70 million clips. Holy crap, man. Rather than seek permission or pay a fair price for the audio-visual content hosted on YouTube, Apple harvested content creators protected in copyrighted videos for commercial use and at scale without consent or compensation to the content creators. According to the YouTubers, Apple also profited substantially by providing its customers with AI features trained on their data. The company's massive financial success would not have been possible without the video content created by plaintiffs and class members, which was intended for streaming on YouTube. And obviously, Apple is going through a bunch of lawsuits right now. They always kind of do some shady stuff, but it is kind of funny because apparently the same YouTubers are actually suing Amazon as well. They also did the same thing. They're apparently using their YouTube videos to train their AI model. Amazon was apparently using those videos to train the Nova Real video AI generator thingy. They all suck. They are all the same to me. Where Amazon is facing a proposed, man, I wish I could close this out. I don't want to see this. What the hell? Where Amazon is facing a proposed class action in federal court in Seattle after 3 YouTube creators accused the company of scraping millions of copyrighted videos from the platform to train its Nova Real artificial intelligence model, according to a complaint filed Friday. The lawsuit was filed in the U.S. District Court for the Western District of Washington by TED Entertainment, which operates the 𝙂𝙚 Productions and 𝙂𝙚 Podcast highlights channels. So the same 3 parties are suing Amazon as well. They reached out to Amazon for a comment, but they didn't get one. The complaint says the creators are suing on behalf of a proposed nationwide class of people and companies in the United States whose YouTube videos were allegedly accessed by Amazon. According to the complaint, Amazon used those videos without permission or compensation to feed, train, improve, and commercialize Nova Reel, a text-to-video model that is available through Amazon Bedrock. Amazon Bedrock? What the fuck is this? Minecraft? So they reference the same DMCA thing, and according to YouTube's terms of service, scraping YouTube content is an unauthorized violation of the platform and undermines the value you provide back to creators in exchange for their work. YouTube's terms also don't allow unauthorized downloading and bulk extraction, that the platform uses several layers of protection to limit access to those files. The creators allege Amazon got around those protections with automated downloading tools and systems designed to avoid detection. So basically, the 3 YouTube channels are saying Amazon did some nefarious stuff. Not surprised, Amazon has been exposed many times also, just like Apple, for doing a lot of shady stuff. But there is one thing that I did kind of find pretty funny about this whole situation. These 3 YouTubers are apparently suing Amazon, they're suing Apple, but isn't it funny because doesn't Google do the exact same thing? Doesn't Google take YouTube videos and use it to train their AI, whatever it's called, VO or whatever it is? I remember reading something along the lines of that where Google was actually using people's YouTube videos to train their AI systems. Now, there is something that you can do in your YouTube settings to go ahead and disable that, but I don't know if Google still does it anyways, regardless of whether you give them permission or not. If you don't know what I'm talking about, go over to your Creator Studio and then you'll see this section over here on the left.
Oh, they'll still
dashboard,
try to.
content, stuff like that. Go ahead and press your settings on the bottom left. Go over on the left to channel, and then you're going to go over here to the advanced settings tab in the middle. If you scroll all the way down, you'll see a section that says third-party training. Allow third-party companies to train AI models using my channel content. If you select this option, YouTube may share your videos with a third-party company provided that you and all other applicable right holders have chosen to allow that company. The training permission status of all videos will be available through a publicly accessible interface. Obviously, I have it unchecked, and I highly recommend that you uncheck it as well, unless you want your videos to be used to train AI models. But it is kind of funny that I guess these 3 YouTube channels don't have a problem with Google and YouTube doing it. I guess maybe they don't have a say because I guess maybe Google can do whatever they want since we're technically uploading these videos on their platform. I don't know the legality behind it, but point is, I do think it's kind of funny. But regardless, Amazon and Apple are actually getting sued by these 3 YouTubers, and they also claim that Apple used those same tools that Amazon did to evade YouTube's protection measures to be able to download all those YouTube videos. This apparently involved using computers with rotating IP addresses to scrape the data. And also, Apple has so many different types of lawsuits that they're going through right now as well. And the 3 YouTubers, especially the ones that are behind the H3H3 Productions channel, TED Entertainment, are actually going after a bunch of other companies as well, like ByteDance, Meta, and Nvidia, with similar accusations of video scraping. So it's weird. It seems like all these different types of companies out there are actually stealing YouTubers' videos to use them to train their AI models. Apple was apparently doing it, Amazon as well, and there were some other ones listed there as well, like ByteDance, Nvidia. Meta, we already know Meta is full of shit. They are probably the most unethical company out there. I absolutely despise them. Obviously, like a month ago, they were revealed to be the people who was actually funding all the ID age verification laws across the world, and it's just such a shame because these guys have so much money and influence. They have so many popular apps, and specifically in the social media space, they have a lot of power, and they can actually use that power to lobby for these awful laws like ID age verification. So them actually being involved in this whole data scraping from YouTube videos to train their AI and stuff, it doesn't surprise me at all. I have like a personal vendetta against Meta. They are just so shitty. But yeah, let me know what your guys' thoughts on the situation in the comments. Your videos are actually being used by all these companies to train their AI models, and I actually wanted to end the video off with one more thing that you guys probably already know what I'm going to say. Rick Song, where are you, buddy? You said
Honestly, I'm not surprised.
Greetings, guys, gals, non-binary pals, and welcome back to another episode of Am I going to keep this video to under 45 minutes long, or am I going to sit here and go wildly off script because I get angry and rant my head off? Stay tuned to find out. I live in an anti-AI bubble. I do not use generative AI. I never have. I have never touched ChatGPT in my life, and nor has anyone in my immediate circles. Everyone I engage with on the internet are anti-AI who hate ChatGPT and that sort of thing, and everyone who I am close to in my life is the same. So I kind of forget that's not everyone. That hundreds of millions of people do use generative AI and use things like ChatGPT a lot. And I am reminded of this quite often, when I go out with people that I haven't seen in a long time. We'll just be chatting, and then they'll be like, oh, I asked ChatGPT this, and I have to take a moment to be like, you just casually in a conversation to me are like, oh, I asked ChatGPT this thing I could have Googled. And And I get taken aback literally every single time. I'm kind of like shocked and like I almost go to say something, but the moment passes because I'm too busy being like confused by the fact that we're just using ChatGPT casually that I like miss the opportunity. And it's just wild to me just how, you know, widespread and normalized the use of AI and ChatGPT is, and how some people use it like so intensely and become so reliant on it. And it's really scary and upsetting. A few months ago, I did a video about people who are in relationships with like ChatGPT and Grok and things like that. Like people who they have romantic relationships with these AI chatbots. Sometimes they get married. Sometimes they even have like sexual relationships with these AI chatbots, and it's terrifying. And I, you know, made this whole video talking about it makes sense that they got there and it's really upsetting and frustrating, but also at the same time, you know, it's really fucked up and we shouldn't be doing that. And oh my God, please stop. The world is ending. And today I wanted to do a similar type of video, except with my favorite subject, parenting. There are unfortunately a lot of parents who seem to have turned to ChatGPT to step in and fill the role of co-parent. They give prompts that allow ChatGPT to like take over parts of parenting, to give themselves a bit of a break, to like, you know, unload some of the mental load that comes with being a parent and just, you know, have some time, because being a parent is really stressful and they need to take a load off, and ChatGPT allows them to do that. Once again, as per usual, most of the people who do this or who make content about it are mothers, and it is specifically mothers who have been assigned the role of default parent. And that is a whole can of worms that we will be getting into. Don't you worry, because a majority of these are, mothers who are default parents sharing tips and tricks. There are a lot of women who have accounts specifically dedicated to like giving you the way to best utilize ChatGPT to make your life as a mother easier. And here is a direct quote from one of those accounts. This is a mom who has 27,000 followers, and her account is entirely dedicated to how to use ChatGPT as a co-parent. And this is a direct quote from one of her videos. If you're drowning in mom life and want a co-parent who never forgets the sunscreen or asks you to write things down, you'll find the exact prompts in the comment, which is so upsetting on so many levels. She's married. This woman is married. She has a husband. Her children have a father. She's a mother of two. She lives with her husband. He is the father and present in their lives, if not present in like, you know, contributing to being a father. And she's obviously like complaining about him being like, you know, a bit useless at being a father because he always forgets the sunscreen and he can't remember how to do anything. So she has to write everything down. So it like uses energy and stress because she has to do everything herself. So she's going to ChatGPT instead, right? And like, firstly, hilarious example, because ChatGPT is not bringing the sunscreen. It's a computer app, phone app, program, whatever the fuck. It's not remembering the sunscreen either. Secondly, you do still also have to write it down because you have to type it in. But that's a separate thing. The problem is really that ChatGPT is not the solution. A new husband a new husband is the solution, or this husband getting his shit together and actually being a present father. You should not need to turn to ChatGPT. You should not need to turn AI into a co-parent. You've got a co-parent. He's literally right there. Don't let him get away with this shit by being like, oh, it's okay. You don't have to do anything because I've got ChatGPT. That'll take over your job. No, that's his job. Don't let him get away with not fucking doing it. All right? Okay, we're gonna start with this TikTok that this was in, because I have a lot to say about it, but I should give you the full context for the whole thing. So this on screen says, 4 months ago, I was so fed up with carrying the mental load alone, so I turned ChatGPT into my co-parent, and here's what happened. Before we even read the caption about what the prompts are and what happened, I am just so unbelievably sad for this woman. Like, this is a woman who is married, lives with her husband, the father of her children, just to reiterate, and also works full time and is here saying that she carries the entire mental load of being a parent and that is exhausting and she needs a break, to the point where she had to turn to an AI software because her husband wouldn't step the fuck up and do his job as a parent.
Up.
She is so exhausted and like can't manage, so she had to like turn AI into a co-parent because she was drowning on her own. And that is so fucking sad. If you are parenting your child alone and you are in a relationship, like there is a co-parent there and you are parenting on your own, ditch the parent, ditch the partner, get rid of him, because honestly, like your workload will cut in half once you get rid of him, because presently you are looking after 2 children and
Hey,
an
Vesper,
adult. You don't need to be looking
welcome.
after the adult.
How are you
You don't
doing?
need to be feeding an extra mouth, cleaning up
Hopefully you're
after.
doing well. My name's 𝙂𝙚𝙣𝙚 𝘼𝙂. I'm a variety streamer. I stream lots of games, chess me, as well as I draw art, and hopefully I'll be doing 3D modeling for everyone here. I'll show you water. But right now I'm focusing on an art study, and right now I'm hyper focusing as all fucking hell on drawing this scythe. But yeah, I pretty much want to get a feel for pretty much different methods of making a foundation, and I feel like a combination. I found a combination of like BRB already, but yeah, a combination of like the skeleton method and the silhouette method. Those two combined actually is helping me a lot.
Extra person, planning for an extra person. These dads, these parents who are like this, who are like not the default parent, a lot of the time are also the ones who are like, oh, my wife made my dentist appointment. Oh, my wife told me I had to be here at this time. Oh, my wife booked the trip. Oh, she packed the bags. Oh, she arranged this for me. She's telling me what to do. Like she's managing the household. That includes the children and her husband. Ditch him and your workload already decreases a lot. You're working full time, get rid of him. Go move to like a slightly smaller house with your kids and your life will probably, most definitely, get a lot easier. Turning AI into a co-parent is not the solution. He needs to either step the fuck up or get the fuck out. Those are your 2 options. AI is not, it's not the answer. That is not a parent. That's, please don't. I understand where you're coming from, but it is not the solution. And then we move into the caption, which explains, you know, what she gets ChatGPT to do for her and how it's helped. And that says, as a full-time working toddler mom, life moves fast. And even with a loving, supportive partner, I still often feel like the default parent. I don't think you've got a loving, supportive partner if you've had to turn to AI to use as a co-parent. I just don't think that's what you've got. I think that's just not correct. And I'm sorry that you think that you have a loving, supportive partner. If you feel like you are carrying 100% of the load of being a parent, you do not have a loving and supportive partner. You just don't. I'm fucking sorry, but you don't. 4 months ago, I hit a breaking point and was like, wouldn't it be nice for a change if I could just turn my brain off and say things like, what's for dinner? What should we get daughter for her birthday? Just tell me what I need to pack for daycare and I'll do it. Oh, there's no grocery list yet? How will I know what to buy? That day, I turned ChatGPT into my co-parent and life got 10 times easier. Now, ChatGPT plans a week of healthy meals my kids will actually eat, writes the grocery list sorted by aisle, finds the perfect birthday gift and helps me write the card, creates daycare and travel packing lists I can just tick off, lets me finally turn my brain off for a minute and breathe. The best part, whenever I ask it to do something, it just does. No follow-up questions like, where do I find that? Or, okay, but which one? It just does. If you're drowning in mom life and want a co-parent who never forgets the sunscreen or asks you to write things down, you'll find the exact prompts in the comments. This one's a game changer, mama. You cannot end, like, you cannot write that entire thing after saying, I have a loving and supportive partner. Girl, no the fuck you don't. You cannot say all that and think that that's true. The entire caption after that was just 100% shade at her husband. It was just 100% being like, I fucking wish I could be the parent that he is. He sits there and he doesn't do fucking shit. His brain is off. I wish that I could sit there and be like, oh, what's the grocery list? Can you write it down for me by aisle? Oh, what should we get daughter for her birthday? Oh, what's for dinner? What are we having for dinner? Like, just tell me what to pack for daycare and I'll pack it. Like, she's just quoting shit that her husband would say to her and being like, I wish that I could be that parent. So she's then like used ChatGPT to like turn into that parent. She's effectively like saying to use ChatGPT how husbands use, like, you turn ChatGPT and the parent that you are, and then you get to sit back and be the parent that your husband is. And listen, I get it. Like, I empathize with that. I completely understand. It's not fair. It is not fair that you are being left all of the weight of parenthood. That's a lot to carry. Like, when you have someone who is there for you and should be helping out, it's not fair. And I completely understand that resentment that you have, that being like, I fucking wish I could sit there and do what you're doing. This isn't the fucking solution though. As I said, the solution is to get him the fuck out, or he needs to step the fuck up, right? Like, handing all of this over to AI is not helping anyone. It is not making your husband into a better
I just realized my girlfriend fell asleep. Sorry about that, chat.
father or a better partner. It is just letting him get away with being shitty without any consequence. And he's like just watching you turn AI into a parent and is like, hell yeah, this is sick. Now I don't have to do anything. My wife is less stressed. That's great. Love that. Also, she's not asking me to do things anymore. Fantastic. You're halfway to a divorce already. Like, just fucking do it. Bite the bullet. Cut him off. Send him away. If you don't trust him to be a parent to your children and are instead talking to a fucking computer, what are you doing? Like, literally, what are you doing? Be a single parent, because you literally already are. And I honestly feel like you would need ChatGPT less if he was out of the fucking picture. I just think you would. I think that that's just what would happen. The saddest part about this to me, though, and like where I stop empathizing, is being like asking for it to pick a birthday present for your child. I do not agree with using ChatGPT to like write up your grocery lists and like pack bags and do all of that, but I at least understand it. You know what I mean? Asking it to pick a birthday present for your child, however, I don't understand. And I think that that like crosses a line that's like going too far, right? That is not like using ChatGPT as like support to help with the mental load. That is just like, you don't want to be a parent. You know what I mean? It's like, it's different, because like buying a present is a personal thing. That is a way to show your daughter that you know her, that you care about her, that you love her, that you see her. Like, that is a very personal thing. Getting ChatGPT to pick a present is you basically being like, I don't know my daughter well enough to pick something. I don't care about her enough to like go out and choose something that she would love. I'm gonna get something that, like, I'm gonna enter all the information of my toddler into this software, because that's a good idea. Love just entering everything about your child into OpenAI. Cool, sick. Why the fuck would you do that? Do we not care about internet safety anymore? All of the information about your child is now just like out there because you couldn't be bothered buying a birthday present. Good parenting. Anyway, you've fed all this information about your child to ChatGPT that now pulls together things and is like, here is a thing that your child would want. You know what else you could do? You could just ask your fucking kid. You could just ask her what she wants. You know, you get kids to write letters to Santa. You can ask like, what's something that you want for your birthday? Not even that, like take her out and see what she is drawn to. You know, like you talk to your child, I fucking hope. You play with her, you read to her, you interact with her. Like, you are her mother, you are her parent. Doesn't matter if you're mother or father, right? Like, you are her parent. You should know her. You should know what she wants. And like, it's the thought that counts. That is a saying for a reason. It is the thought that counts. It means so much more getting something from you that you believe that she will love and be happy with than it does to be like, oh, this algorithm told me that she would like this, without you having any idea why she would like that. You shouldn't need to do that.
Oh, thank you, thank you.
Like,
Oh, thank you for reminding me to hydrate. Thank you, thank you. And welcome, welcome. How are you? Hope you're doing well.
just fucking know. Gift giving is a love language, and handing that over to AI is just like removing humanness from the relationship you have with your child. Why are you removing yourself from that? I just do not understand. I don't get it. And there's a lot of this too. Like there's a lot of, you know, not only people who are, you know, default parents using it to take the weight off on things, feel just like, you know, like the necessities that feel annoying, right? Like it's hard to do things that you have to do, and like not things.
I'm primarily focusing on proportions and anatomy, because I just want to make sure I actually focus on it, and I do want to improve on my art. And what I began doing is using a combination of the skeleton method and the silhouette method, which helped improve my art dramatically.
That you want to do, right? Like I understand, again, you know, getting it to write grocery lists and doing all these tasks that are like necessary but feel so fucking annoying, but they're handing it over to like other things that are like very human and important and like actual like core relationship moments, and that is so much worse, and there's so fucking much of it that it makes me so mad. Like she posted a video that was where she said, I asked moms their most unhinged ChatGPT hacks, and some of them were borderline genius. And the first one, and this makes me so fucking mad, says, this doesn't make the day easier, but I tell chat the names of my kids and what we did that day, and
thank you for following. Welcome.
It's so cute seeing.
I hope you enjoy your stay. Feel free to lay back, make yourself at home. If you have any questions, feel free to ask me. And feel free to chat. I'll try to look at chat as often as possible.
Them light up hearing the story of their day. My fucking god. In general, right, there are a lot of these parents who are saying they ask ChatGPT to just like make up stories, to tell stories, when, you know, they could just get a fucking book. You should be reading to your child. That is a fundamental part of raising your child. It teaches them to read. It like creates a bond between you. It's spending time together. It's very, very important for you to do that. You shouldn't just be telling ChatGPT to like tell them a story, because who the fuck is getting anything out of that? No one. And this is even worse. This is even worse than just getting some random story being made. The fact that like you cannot just do that your fucking self. Why are you asking ChatGPT to do that for you? Why are you going to ChatGPT, giving it your kids' names and what you did for the day, and having it write a story? What the hell is wrong with you? What are you fucking doing? Can you not just do that? Can you not just like sit down with your kids and just recount the day you just had, but make them into fucking dinosaurs or something? What is ChatGPT doing that you could not do? You do not have to write a phenomenal book. They are toddlers. They are small children who just want to be the star of a story. You are their parent. You were there for that day. You experienced that with them. You making up and telling that story shows
don't worry, I'm
focusing on work. That was an important memory for you.
And don't worry about it. Just focus on your work. Remember, you're doing a fantastic job. Oh, thank you. Thank you for calling me a good girl. And you're also a good boy, good girl, non-binary pal, and everything in between. Alright.
you as well, that you had a good day. It is you connecting with your child. It is you creating memories, not only for them, but also for yourself. If it is not coming from you, what are you doing? Like, what are you fucking doing? I just don't understand why you wouldn't want to do that. What is stopping you from doing that? Why would you hand that task over to AI? I cannot even begin to fathom why that would not be a task you would do. What are you afraid of? That your story's not going to be good enough? They're fucking small children. They're gonna love your story. My best memories of my childhood, my favorite memories, the ones I have held on to the most, that I remember the most, are the stories that my mom would tell me when I was a kid. I fucking loved the stories my mom made up for me. There were two specifically. This is how well I remember them. There were two different characters or story types specifically that my mom would tell me. There was Felicity Fairy, which was this fairy named Felicity, and I was there and all my friends were there, and I would effectively tell my mom what I liked, what I wanted, and she would just make a story about me and my friends as fairies and talk about things from my life. Oh, the other day we all got together and ate cake, and that would be incorporated into the story, but we were fairies. Fucking loved it. That was so good. When I got car sick, mom telling me stories made me less car sick. So we'd sit in the car and she would make up those stories for me. And the other ones that are genuinely have helped shape me as a human being were these stories she told me called Treaty and Freedy, which were about these tiger cubs called Treaty and Freedy. And when I was really young, they started off as tiger cubs who were 3, because that's how wide I was when she told the stories. And she just told her own stories through these tiger cubs. And then when I got a little bit older, when I was about 6 or 7, I still loved these stories.
6, 7.
But she changed them and adapted them, and now these tigers were 18 and they were traveling the world. And my mom would tell me her travel stories through these tigers, because my mom traveled to 60 countries when she was in her 20s and 30s. She did a lot of traveling, told me her travel stories using these tigers that she'd told me stories about while I was growing up. And I begged for those stories. I loved those stories. They implanted in me a love for traveling. They inspired me to want to create my own stories. They have made me fall in love with the idea of seeing the world and compiling my own stories that I will have to then pass down as well. They they are such a core part of me. They have helped make me who I am. They are still something that I learned so much about my mom and her travel journeys. And so I go to the places that she went to and we get to talk about them. And I have so many stories that I share with her and vice versa. And it's all because she told me these stories when I was a kid. You are denying yourself creating this beautiful thing in your child that you can grow with each other, right? Stories help make you into who you are and shape you into who you are. And this is something that is they are memories that I hold on to. Even the stories that my dad made up for me. I do not remember a lot of my childhood with my dad, but I remember the stories he told me and how much those meant to me. I remember the lullabies that he would sing me as a kid. It's those things, those human connection moments, those it's beautiful, and it's so fantastic, both as the storyteller and the person who gets the story. You were sharing something special and you're just handing that over to fucking AI. For what? No one is gaining anything out of that. Your kids might be happy, but they're not remembering that. That is not making those moments special. It's not doing anything. It's temporary entertainment and nothing deeper. You could be creating something so strong with your kids, but instead you're just taking the easy way out and doing nothing. And I just don't get it. The best parts of being a parent are the parts that you get to enjoy and share with your kids, and you're not even doing that. Another one that is mentioned in this, hacks that moms share, and that she has mentioned a bunch of times herself as well, is I prompted to create a recipe with what is left in the fridge. I think it helps with the mental load. There's this whole thing around, entering in what you have in the fridge so it can create something to cook with all the things in the fridge, so you don't have to, have things go off or go out and do more grocery to add more things and make things. And this is frustrating to me in the way that you don't have to do that. I feel people make cooking into something that is so much harder than it actually has to be. Literally just throw it together. Firstly, what's in your fridge presently is all stuff that you've already used to make other stuff. Just make that thing again. And if you don't want to repeat recipes, you know what works together, right? Like, you know what flavors make sense together. Just do that. You know, if you've got a ton of vegetables, chop them up, throw them in the oven with some olive oil, salt, and a herb or seasoning of your choice. Then you have some fucking roast vegetables. Do you know how many things you can turn into a pasta sauce? There's so many things that you can just like cook and then blend with some like veggie stock or cream or something. And then you've got a pasta sauce. You can make soup out of a fuckload of things. My mom used to make something she just called like a mumble jumble, which was just rice and then whatever was in the fridge. Like, it's so easy to just get stuff out of your fridge and make something. It doesn't have to be anything. If the ingredients are things your kids like, then it's fine. They don't care. It doesn't have to be a thing. Just make stuff up. My entire childhood, like my whole life, most of the cooking I grew up with was my mom just being like, here's what we have on your plate. Like, they don't care. It's food. You've got it, cook it. That's even less work than having to type everything in. Just like cook it. You know? That's making your life easier than like going in and typing everything into ChatGPT. And then in the comments of this, people obviously went and commented some more of their ChatGPT hacks. And this one bothered me the most. And that was, I use it to randomly select which kid gets to go first, who has to sit in the back first, who gets to cut the cake versus pick their piece, etc. They tell me now, ask ChatGPT who gets it. Firstly, isn't who cuts the cake the birthday person? Or are you just having cake more often? Maybe I just only think of cutting the cake as a special thing on birthdays. I never cared otherwise. Maybe that's something kids care about. Anyway, regardless, that is beside the point. Whatever fucking happened to rock, paper, scissors? Eeny, meeny, miny, mo. 21. Coconut crack. I'll think of a number. Whoever guesses closest wins. Whoever rolls a dice and gets the highest number. Like, there are so many ways to choose who goes first that are not just like telling ChatGPT their names and getting them to randomly choose someone. And all those other options I just gave you are so much more fun. It's so much more fun. It's like, it's fair. It's something that they participate in. It's like a real thing. It's like games. And you're just instead being like, here are my kids' names. Choose one. That's so boring. You could even put their names in a hat and get one of them to pick their name out. Like, just keep their names on pieces of paper. And then like, when it comes time to go first, you hand it out and they pull it out. And if you want to make it so everyone gets an equal amount of times going first, once their name has been drawn, it stays out until all the names are gone and then they all go back in. That way everyone's getting a fair amount of times of going first as well. Like, there are so many alternate options. I don't even know why people think that like I just cannot imagine my brain being like, oh, I'll ask chat. You know, like, what are you doing? What are you doing? The closest I get to doing that is I do use like those wheel spinner things a lot, like
I don't know how to pronounce it. Thank you, FA, for
like deciding who goes first. Deciding who goes first.
Thank you, FA, for following. Welcome. How are you doing today? My name is Brain Blitz. I'm a Friday streamer. I stream lots of baking and chat suggest me as well as I draw art. And hopefully I'll be doing 3 more for everyone here. Welcome. Feel free to kick back, lay down. Feel free to kick back, relax. Make yourself feel at home here. If you have any questions, feel free to ask. Welcome.
Is usually going to be a paper, scissors, rock kind of situation, but all of the options I just gave I think are equally as good. But if I like can't choose what,
Also, we do have our Discord linked in our about page, so feel free to join our Discord server there.
to watch or whatever, I'll just go onto like a wheel spinner app. And also that's way more fun. Like typing in like a bunch of movies and being like, which one should I watch? And it just gives you one. That's boring. If I'm gonna be using the internet to do something like that, I'm putting it in a wheel and I'm watching it spin. And then it's gonna tell me the answer with like confetti, because that's way more fun. And like, it's still so much more. I just think it's just so sad. And like, especially here, right? Like she ended this with thinking it was funny, being like, now they ask chat. They ask me to ask chat. I don't think you're thinking of the like long-term consequences of that. They aren't like, they're not asking you. They're not going to you. They're asking for ChatGPT instead. They're not asking you to make a decision. They are asking ChatGPT to make a decision. That is going to end poorly for you. That is, you have handed over authority to ChatGPT. They are going to ask for that instead for this situation. There are going to be other situations in which they're asking for it as well. They are going to like stop looking to you and go above you because they see who really has the authority, and it's not you. It's a fucking robot. And somehow you think that that's a good thing? I just don't get it. You're taking the fun out of parenting. This is what is so fucking confusing to me. There are aspects of parenting that sure like seem stressful. There are also aspects of parenting that seem like really fucking cool. And like taking out the storytelling and then taking out the like giving them games to like have independence and instead asking them to ask a fucking robot. Like if you've got a group of kids, give them a game and be like, do this to decide. That's so much more fun. You get to watch them have fun instead of you're getting your kids to be like, oh, please ask the fucking robot for me instead of paper, scissors, rock, instead of fucking coconut crack. Like, what are you fucking doing? Anyway. There are also just so many people who use it as like a Google search engine, right? Like some of these comments are like, I tell it everything I ate and it tells me about the calories and macros. And I don't agree with that.
Thank you for Miko for following. Welcome. How are you doing today? I'm so glad you landed here. Welcome to Blitzy. Feel free to kick back, relax, make yourself at home here, and if you have any questions, feel free to ask. Also, we do have our Discord server in our about page, so feel free to join our community there.
You don't need to use ChatGPT for that. You shouldn't really do it in general, but like there are literally apps for that. And then I got it to summarize a book for book club because I didn't have time to read. Just don't read the book. You don't have to read the book, okay? No one is making you read it. Book club is meant to be fun. It's a hobby. Reading is a hobby. It shouldn't be stressful. It shouldn't be something that you panic about if you don't manage to read the book. You can just tell them you didn't have the time to read the book. You can't just get ChatGPT to give you a summary and be like, I read the book, guys. Let's have a conversation. Be a person and have a conversation and be honest. And like, you can still participate in book conversation because you can gather the like idea of the book or get one of them to help you like with the summary of it. Or if you really just want to like summarize the plot and like go in and have some sort of knowledge of what happened, go to the wiki for the book. Go to Wikipedia. Like that's ChatGPT is just going to copy it from there anyway. You don't need third party. You do not need to be using ChatGPT. It's just taking information that is already there and it's just so unnecessary. And it just bothers me so much how many people just go and use it like a search engine when the search engine is right fucking there. You can search it and find the answers in literally the same amount of time.
Here's the thing with the search engines. Yes, you can use search engines. I often opt to use search engines as well. However, I want to say that engines like Google Chrome and pretty much DuckDuckGo is using AI for the search engines for pretty much search queries and stuff like that. What's even worse, that now all these search engines, all these companies are pretty much actively using AI to rewrite what the web results web results say. So the web result, the brief description of a web result, it often says something completely different to what the article is saying. Plus, it can get pretty much they're getting things wrong on the search engine. The AI is getting things wrong, pretty much changing what the article is saying, is actually saying, and I fucking hate that. And unfortunately, we don't have a choice. I'm forced to use like ChatGPT for some small shit, or pretty much for like research, like I don't know, into like PC building and stuff like that. And I still opt, yeah, but even then, if I can't get something for ChatGPT, that's when I go into full stubborn mode and search far and wide and search every nook and cranny in every corner just to get what I need.
Just fucking do that, because using ChatGPT is like environmentally detrimental, obviously, right?
Hi Vince, welcome. How are you doing today? Welcome. I'm so happy you landed here. Feel free to kick back, relax, and if you have any questions, feel free to ask. We also do have our Discord server linked in our about page, feel free to join our community server there. Welcome, welcome.
Just causing a reliance, right? Like people are using it as search engines because they're also chatting to it, and so it's working out all this stuff about you and learning about you, and also like just use a search engine, please. This next one,
Even search engines to learn about you.
This one got me. This one really fucking got me. So I'm gonna take a deep breath before I watch it, and I'm gonna get all of you to take a deep breath with me, okay? Okay, let's go.
AI is not only essentially free childcare.
Stop already, right there.
What the
AI
fuck?
is essentially free childcare?
Hell no.
Stop. Shush. Shut up. No. 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 Oh my god. Oh my god. No. What do you mean AI is essentially free childcare? It can't watch your child. It can't care for your child. It's a fucking computer software. Is it? Pardon? It can't ensure your child's safety or watch it or make sure it's okay and not like choking. What do you mean it's free? Okay. And anyway, I did say to take a deep breath. It clearly didn't work.
But it's also going to enable an entire generation of gifted kids. And if you don't know me, I'm Harper. I'm an AI expert. I have about 10 years of experience from Stanford, Meta, company acquired by NVIDIA. I engineer AI. Check me out if you want to learn more. My goal now is to teach everyone AI so we can all use it and understand it to our benefit. If you have a kid, and I don't, but I have many friends who do.
I'm glad you don't have a kid because you view AI as childcare. And it is absolutely not. So keep on the no kid line, because yeah, okay.
They are constantly asking questions, constantly. These questions that often we don't know the answers to, or we don't remember it from science class, but AI does. There's a
Well, she was paid to say
ChatGPT
this.
where you can just basically tell the bot, hey, you're about to speak to a 5-year-old, so answer all questions at that level of understanding. And it can talk to your child at whatever age they are, 5 or otherwise, and answer their questions for hours. And so rather than shutting down your child's curiosity because you don't know the answers to the questions or you can't talk to them constantly and entertain that curiosity, you have this AI bot now that can. And so they can just have these long conversations and you know, my friend said it's free childcare, essentially free childcare, you know, $20 a month. And it's so exciting. And I think it's going to bring in a whole generation of gifted kids because kids are actually going to be able to pursue exactly what they're most curious about. Just any time, at any time of day, any question that they have, they can ask. How exciting is that?
Oh my god.
Jesus Christ, what am I even listening to?
To every single part of this? No. I love this just being this. It's like the new iPad kid. It's being like, instead of being a parent, just hand them a device. Hand them a device. That'll keep them entertained, and then you don't have to do anything. This isn't any better. Honestly, I almost feel like this is worse.
It's so much
if you're
worse.
giving your kid like an iPad with like games and shit on it, at least they're like, I don't know. This feels it's like on par, but almost worse, just because you're leaving them unsupervised while being able to ask questions and have them being answered, and you don't know what they're asking and you don't know how it's being answered. Tell ChatGPT to answer at a level that a 5-year-old would understand. How does it know what a 5-year-old is going to understand when every single 5-year-old is different, and also every single 5-year-old is going to be asking different questions? I don't know about other 5-year-olds or younger even. When I was like 3 or 4, apparently I, would ask, where do babies come from? As do many children, right? And there are age-appropriate ways to answer this question. Obviously, when I was that age, I didn't like any of my mom's answers, so she got an age-appropriate book and she like gave me the answers that I wanted. That was true. I don't remember it. Blocked it out apparently. But, and I think that those are important conversations to be having with the child. Yes, absolutely. And like, it's good to have those at an age-appropriate level, sure. But I still think that's something that you as a parent should be doing and not leaving an AI to do for you. That is a very important part of parenting, is like being in control of those conversations. Secondly, when I was 5 years old, some of the questions I was asking? Where was I before I was born? What happens after I die? What happens when you die? What happened before I was born? Why can't I see the world through my friends' eyes? Why am I me and not them? Those are the questions I was asking when I was 5 years old. How the fuck is ChatGPT gonna handle that? What's it gonna fucking say? What is ChatGPT gonna say? You're speaking to a 5-year-old when they ask, what happens when I die? I don't think that's something you should be leaving your kid alone with a chatbot. You know, like, do you know how to answer that question? No, no one fucking knows the answer to that, but it's definitely a conversation that you need to be in charge of. You need to be aware that your kids are asking these questions, because like that is very important to know what your kids are curious about and to know, you know, what their interests are and what they're like leaning towards. And especially when it comes to big existential questions like that, like it's a signifier of like, you know, who we are emotionally and like what direction we are going to move and like what we need in our lives. And you are not in charge of those conversations. You don't know those conversations are being had. You are leaving your kid unsupervised, not knowing anything that is happening. Anything could be happening right now.
Hi Ark, how are you doing? Welcome. Also the fact this is probably even worse. This is pretty much equivalent to unsupervised internet access. Remember Gen Zs, millennials who are watching? Remember we had unsupervised internet access and pretty much we ended up pretty much finding the most horrendous shit on the internet. And it was just, this was on the surface web, on the surface, even on an easy YouTube search, you could find it back then. This is so much worse. This is so much worse. Because AI is not regulated. Pretty much data AI now is what YouTube used to be back in 2009, 2010. Holy shit. But they have even more information. You have access to even more information. Holy shit.
You know, kids love magic, right? What if your kid like asks, is Santa real? What is ChatGPT gonna say? What if it fucking kills the magic that your child has? What if like your kid asks about like fairies and magic and pixie dust and all of that, and ChatGPT just squashes the magic for it? Or it like says something that they don't like and that makes them upset, and you aren't around to control that or be there for that conversation. What if ChatGPT validates the monsters that they're afraid of, validates the monster that's under their bed, or makes it more scary? Like, there are so many ways that a conversation with AI can go completely haywire because you are not in control, especially if you are leaving them alone for hours. You're gonna get your kid to talk to AI for hours? Why are you a fucking parent? I just don't get why you decided to have kids if you're not going to talk to them. A part of parenting is answering questions. Kids are curious. They are learning about the world. They are brand new fucking humans. They don't know how the world works. They're learning things. It is your job as a parent to answer their questions, to teach them, to guide them through life. If you aren't doing that, you aren't a parent. What was the point in becoming a parent if you don't want to do that? If you're like, my kid asks so many questions I don't know how to answer and it fucking pisses me off, so I leave them alone for hours, what are you fucking doing? Quite literally, I just do not understand. If you do not have the time to talk to your kid, to entertain your kid, if you don't have the patience for it, the time for it, anything, why are you a parent? You do not have to have kids if you do not want to be a parent. It's that thing of like, I understand the desire to like take some of the weight of parenthood off your shoulders. If you are being given so much mental weight to carry, understand trying everything you can to like alleviate some of that stress. But this is not one of those things. This is just like the best part of being a parent. Playing with your kids, teaching your kids, being
I love how I made the site so much. I'm pretty much gonna try to see what I can improve on it on the next time I draw the site. But holy shit, I love it. Also, there we go.
there for your kids. Like, that is That is the most beautiful part of parenthood. You know, when I think of the potential of having kids, it is like these things that make me want to do it, right? There are so many parts of child care and like being a parent that sound so stressful and so difficult that make me be like, I don't know if kids are for me, but there's these parts of like answering questions and teaching them things and like giving them presents and like knowing them and like watching them grow and teaching them, that is like fucking beautiful. And it would be an incredible thing to be like a part of that and to watch like this tiny person become an adult. Like that's so fucking cool. And you're not even doing it. So like, what are you fucking doing? That is also not going to raise gifted kids. It's going to raise neglected kids who don't know how to have a conversation with a person and who do not have a relationship with their parent. You are teaching your kids to not come to you. You're teaching them to not ask you questions. You are teaching them to not have conversations with you. You are teaching them that they are not worth your time. They're not going to come to you with anything because all you've done is told them like, oh, if you have any questions, ask ChatGPT. If you need anything, ask ChatGPT. You have made yourself obsolete as a parent. You are letting your kid be raised by ChatGPT. Why are you fucking doing this to yourself? What is the fucking point? This is not how gifted children are raised. Gifted kids, curious, sure, or curious kids are gifted or whatever the fuck. I don't really know how it works or even what it all means. But like, it's about how, you know, it's about EQ. They always say that like gifted kids often, it lines up a lot with like empathy and emotional intelligence, right? And so by denying them human interaction and communication, you're actually doing the opposite of that, right? You're not helping at all. You're not like helping with their curiosity. You're just leaving them unsupervised to do nothing and just learn to not ever talk to people. Like if you do not know how to talk to your kid and your kid does not know how to talk to you, you have fucked up immeasurably. And you like may as well just not be a parent. And I don't know what you're fucking doing here. I don't know why you're a parent. You're really not even. You're just not. This leads me into this next TikTok that also just pissed me off so bad. And it makes me so fucking sad. And that's this. Trying to teach my 6-year-old daughter how to handle bullies. What she typed in the caption, asking ChatGPT, what advice can I give a 6-year-old who is getting bullied? And this is what it was.
She makes you guys cry a lot. She's a bully to you guys. Yeah, that's not okay. What did I say to tell her?
You're very mean to me.
And I don't like that.
I don't like
All right.
that. And I don't want to be your friend. I will be your friend some other day when you're nice.
Yes.
You're telling me that you had to go to ChatGPT, learn how to tell your 6-year-old child who is being bullied, tell the person bullying you, you're being mean, that's not very nice, I don't want to be your friend until you're nice. You had to ask ChatGPT to say that. What are you doing? What are you fucking doing? You need to go into parenthood being prepared to have these conversations, and you definitely should not need to go to AI to figure out to set boundaries. I don't understand how you can't just know to tell your child, I'm sorry that someone is being mean to you. That is so terrible. If it happens again, you need to like tell her that she's being mean. You need to stand up for yourself because, you know, you're great and I love you, and don't accept when people are being mean to you. Like say, stop it. I don't like it. Don't do that. You're being mean. I don't like, these are all things that you should just like know what to say. You are a person. Your child is a person. You should know how to say these things. You should know how to have these conversations. And this is like the most basic form of this conversation that you could possibly have. This is the most simple conversation ever. And
Alrighty, chat. So far, I'm actually very satisfied with how this had turned out. Next art session, we will be working on her clothes, and pretty much just using the same clothes we used last time. I'm often like, I'm trying to see where it can go from like a dress to more of a combat suit sort of thing. Well, as minimal and pretty much minimal, practical, and still suits her style.
The fact that you needed to get ChatGPT to tell you how to have this conversation makes me
But yeah. So far, so good. But yeah, I'm pretty much going to be ending off the stream here. But I do want to say, just thank you to everyone who followed, who subscribed, and pretty much, who are still here supporting me. It does mean a lot to me, and I do pretty much want to give back to my community one day. If everyone still needs, I do still we do, okay, for Kick, we do have the Discord link in our about page. For Twitch, we do have our commands. That's our Discord, and we do have backup servers as well, just in case Discord goes AWOL. As for YouTube, we do pretty much all the Discords we have for YouTube, we also have for Twitch. Pretty much, I mean, what the fuck? But yeah, for YouTube, we do have our we do have Nightbot for YouTube as well. And it's just Nightbot is a lot slower on Twitch than it is on YouTube. Pretty much, yeah. Anywho, let's see here. And as for our joystick, I didn't bring our both Discord link and our two servers. There you go. But yeah, pretty much you can be ending off stream here. I just want to pretty much say thank you everyone for following, thank you everyone for subscribing, thank you for supporting me. We do have ways to pretty much, if you you don't have to, but pretty much there are ways to donate. We do have 3 tip commands: tip 1, tip 2, tip 3. There's 3 ways pretty much, and also like subscribing to our Twitch. We do have our Discord server. Feel free to hang out there. I am mostly hanging out in my Discord server in the voice chats. And with that being said, I do hope everyone has a good night. I do hope everyone has a good day, evening, night, time zone. So that's what we're gonna do for like the rest of the night. Just relax a bit and just go to sleep. Yep. Oh, thank you. But that being said, just thank you everyone. Just thank you. I appreciate you. I finally reminded myself to raid someone. To pretty much do a raid. Bye bye. I can see if 𝙂𝙚 is on. I can see if 𝙂𝙚 is streaming or not. Oh no, she's not streaming. But yeah, I usually don't do raids. I usually don't do raids, but yeah. That being said, thank you again, and I hope you all have a good rest of your night. That being said, gotta get going, Blitzies. Bye bye matinee.
Open eye, feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the sky.